Well, Lars, I really hope you've got that mine doors tarped and sandbagged now. I think muriatic acid tends to lose more oomph over time because it's basically a gas dissolved in water. So is nitric, but it's less volatile to my belief. It also depends on the packaging. But I've got nitric acid that's at least 5 years old. It's still working just fine. Uh, Muriatic, I think, is not as quite as durable. Don't know for sure. The nice thing about muriatic is it's cheap to buy more. Nitric, not so much. I presume the video and audio are doing just fine, everybody. Oh, yeah, Lars, you got that door secured this time? So I'm thinking sandbags along the sides, tarp, more sandbags. Oh Lord, what a mess. Thanks, Jeff. Hey, Mr. Lodak. Oh, dearie. So it's been not as productive a week as I'd like because, well, this Christmas thing, everyone wants to do something besides work for some reason. And last week was dangerously cold temperatures. So we pretty much stayed at home for about 4 days, had some where I did some reports and this and that and the other. And I don't know where that one got off to. I think I just put a copy in your experiment book, little one. But anyhow, did a lot of um, correlation of data and things like that to try and figure out what's worked, what hasn't worked, what we still don't know whether or not it's worked because I can create more samples for Eva to assay than she can assay in real time. So although she's working very diligently, I can bury her. So we look at things and decide, okay, can this sample wait? You know that, for example, when we were doing elution tests, which is what most of this data was, we'd try a solution and to a certain extent we'd look at the color of the solution. The hydrazine was clear, right? That was the one that was just clear.
That was just clear. It didn't. The beads changed color. The hydrazine didn't.
Yeah. We put, for example, we tried some with hydrazine sulfate, and there was just no coloration to the solution at all. So it's like, well, that doesn't look like it's working, so we'll put that on the back burner. But Eva's got a lot of. I mean, you could probably go nonstop for 3 weeks just to get caught up, huh? Due to the size of your furnace.
Yeah.
Yeah.
Well, about 2 weeks if you produce nothing else, and I would go through everything I have.
Yeah, that's what I'm saying. So as I say, it's not her fault in any way, shape, or form. She's been working harder than I have been. Um, but it's just because she only has this furnace that can do one sample at a time and such because of its size, she's very limited. Um, we'll probably be working on upgrading that in the not too distant future here. There's a number of possible ways of doing it, but it's just one of those deals where she's doing the best she can with the tools she has. If she had a bigger furnace, what could you probably do about
Before,
4 to 6 a day?
Yeah, before we changed the configuration of the furnace,
Yeah, well, I'm sorry.
I
Now it's
could
not
get
burning up.
8 smelts to button point in a day.
Mm-hmm.
And then I could get 8 buttons, 2 beads, and parted and into gold beads in less than a day.
Okay. So anyhow, I say you can see the thing, and it's kind of frustrating because the furnace itself, when we relined it, just brought it each side in a half an inch, and that was enough to screw things up. So Say I'm working in my head a little bit on some plans of maybe a 220 volt furnace for cupelling and stuff, and small testing. Um, we might we'll probably talk to Max and see what kind of furnace he has. He said he's got an extra one that he could give me, um, and so there's possibilities there. Say it's just one of those things that got so many things on our plate. The one thing that, of course, we've been working on, which is the high priority, is getting the gold out of the resin with minimal losses. And possibly Lars, I got no problem with that. I'm thinking something, let's say 220 volts, each element 110 volts. So we know basically what they're going to do. We know how long to make them, this, that, and the other. An internal space of at least 1 cubic foot empty space, which means probably a furnace on the neighborhood of 18 inches on each side, and probably about that high, because again, like this, you probably have your controls underneath just because it works well that way. Keep it out of the heat. And then use better insulation and better structural. Hey, Shaggy. Better structural things for the heating elements. We found the laying them on a shelf really improves their lives. But one thing I was thinking too was, one problem we found is that getting the heat through the sides of the crucible is not efficient as raining the heat, radiating it down onto the top of the charge too. So the sealing elements come in handy. Hey, Scotty. And so my thought was, if we were to take, the coiled elements and hang them on ceramic rods that just rested in like little notches on top of the wall insulation, then that'd take a lot more power, Lars. Then you could, keep those overheads well supported easily. You don't have to worry about stapling anything or whatever, just hanging them on ceramic rods. And I think that might work real well. I was also thinking it'd be a lot easier to service the damn thing if the whole lid fit on, maybe a couple screws to hold in place. But then when you wanted to take off the lid to work on the upper elements and things like that, you just pull 4 screws and pop it off. And now you can work down from the top also. So, I mean, there's no reason you couldn't make the lid of the thing pretty self-contained, so to speak. Not sure. I'm really running into a problem finding basically like, what was that? Aluminum oxide ceramic sheet. We got lots of ceramic fiber board. And I have had bad luck with the ceramic fiber board I got because the layers tend to delaminate. I want something I can groove, I can cut, I can shape, and it will stay. Kind of like if you were dealing with styrofoam, but some kind of ceramic material. Hey, Chris, how's it going? You can buy them. I have. Sounds good, Lars. You're going to want something like aluminum oxide for the refractory. I mean, you need something that really can get hot without sagging. But, I mean, we'd only need them about 12 inches long for this size furnace. Anything bigger than that, and I'm not sure how many amps you're going to have to pull and what size elements and things like that, but we can play games between, me and Chris and Lars, we can probably do it. Um, but Eva could do a heck of a lot more if she had just a bigger furnace. Everything else is easy to scale up. If you don't have a big furnace, it doesn't do a damn bit of good. Um, I'm not sure how well fire brick would work. Possibility. There's also castable refractories, which we could probably reinforce, um, and just cast various things. Like Lars could potentially uh, use his CNC router to make molds out of um, styrofoam, and then pour a layer of castable ceramic in there, lay a steel mesh in there, and then pour another layer, and we'd have a solid wall with shelves built into it and things like that. And then between that and the outer wall of the kiln, you could use like KO wool or something. Now, KO wool it's a ceramic fiber. It's actually like melted rock of some sort. Um, it's a high temperature insulation. It's very good insulation. It has no structural strength. It's like fiberglass, and you want to keep it contained because the fibers themselves are like asbestos. They're bad for your lungs. So you like to have it sandwiched between something else, ideally. But I say it has no structural strength either. So my thought is, if you had inner walls, hello Asakura, um, either out of like an aluminum oxide foam or some kind of castable ceramic that we do, and then KO wool on the walls. Um, that might work just fine. For the door itself, not that critical. You could use KO wool, and you could put a liner on it, all kinds of different things. Because structurally, it doesn't have to have much on the inside. Outside, yeah, you need a good outside and frame around it, but that's it. So that's in the very, very early stages of the thought process, um, but seems pretty doable. Um, and then Eva could get a lot more done once we figure out exactly how we're going to process the resin. That also might, give us a new priority. For example, we may want to build just a gas fired furnace to begin with for making large, uh, well, Ricky, the thing is, we're loading a bunch of crucibles, would be the idea. So they're all going to be in an array, and you'd need a door. Now, while you can, uh, use a top loading kiln, you lose a lot of heat that way. Plus, it's not as easy to deal with as things like when you got a little cupel sitting there. It's a lot easier to reach in sideways, grab it, and pick it up than it is to come in from the top with all that heat coming straight up and get it. Um, so there's big advantages of a side loading
Side
furnace.
loading furnaces rock.
But for big batches, the cylindrical gas fired furnaces, they're hard to beat in terms of efficiency for cost. It's not easy. It's awfully difficult to beat it.
I couldn't pour the things that would be melting in them.
Yeah, I'm talking about big crucibles, 10-pound charges in it. That's what I'm talking about.
Yeah, which you guys would have to handle.
Yeah, I say
take all the fun away from me.
We're not talking assaying here. We're talking production potentially. So I say that kind of has to wait until we find out exactly what we're going to do. However, in the why do you need the pointy top then, Ricky? I mean, you got a series of cylindrical objects that are wider at the top than the bottom. So if the walls come in like this, you're going to have a lot of space that's not. I just don't see how it's very efficient in terms of interior space. And fabrication also becomes, yeah, I've built pyramids before. They get a little more complicated than a rectangular box. Rectangular boxes are pretty easy to fabricate, which is important. I'm trying to think. We didn't. Come on. Are you on? I wish they'd make lights on these things that were a little brighter. Yeah, it's coming on here. It would limit heat rise. My mind's not really picking it out. I mean, I'm not visualizing what you're talking about well enough, Ricky. If you want to send me kind of a diagram or whatever, we can see. But I say the idea is to simply, you're going to have elements. If we're using an electric furnace, you have to have elements. They have to be supported. And if it was an inverted pyramid, they could be laying on the walls like that. But hanging causes problems. You could use less energy. Once the big energy use thing is more the insulation than anything else, Ricky. Because all the heat's radiating around in all directions. And so the question is, how good an insulation do you have between the inner wall and the outer wall? And that's probably by far your biggest factor in that. And then again, the question is, how many crucibles, how many square inches of outside surface do you have per how many crucibles at one time? Would a handhold, I guess Southwest Mining retracted that. I'm not sure how induction works. I think you can do it with special fluxes. I know that Lauren did one with a microwave where he had like an insulated box, and that's the kind of material I'm talking about, Lauren. If you're back from fishing, that's the kind of material I'm talking about. What you made that box out of that went inside the microwave, that's the kind of material I'm looking for. I know they make it. I'm not sure how expensive it is, but I've actually seen it. And it wouldn't be too hard to fabricate that stuff. And it's also pretty foamy, a pretty good insulator. So I think it would work well if it's not extraordinarily expensive. But the two things that we were doing, and let me go ahead and print this up a little bit here just so you can get an idea. Come on. That stupid thing there. Always got to be in the way. Let me go ahead and make a print because I printed up a copy for the boss and a copy for Eva, and I don't have a copy in my files here. So I ought to make a copy for my files. But what it was, oh, come on. Why are we not showing up, you stupid computer? Hello? There we go. Experiment report, elution solutions. That's the one. File, print, copies, one, print. Okay. So the two lines of attack we've been using on the resin: ashing and elution. And the ashing, the big problem was that it's a bit slow and it had high losses. So we went and here's all the different things we've tried so far. And there's 1, 2, 3, 4, 5 solutions where we have not compared the post-elution fire assay versus ash plus fire assay. that we actually have resin for, and then 3 that we don't have all the resins we need. However, we have already found one where we only lost 6%, one where we only lost 0.7%. Here's another one at less than 1%. Here's another one at less than 1% losses between the ashing and the, ashing plus fire assay versus straight fire assay. That's correct, Lars. And you also have to have it where it's going to fit under your exhaust apparatus to keep you from dying. So there's a number of things that would need to be put in there. It wouldn't be a bad idea to have the ability to capture the exhaust and run it through a scrubber in case you were losing something you might want to capture. I can't imagine how that could happen. But anyhow, so I said we found 4 so far where there seems to be minimal losses with the ashing process. We found that's assay interference there. We found like 3 different solutions that showed some ability. Okay, Chris has sent me a link here. Let me see. This is probably ceramic fiberboard. Now, I'm not looking for fiber unless it's a lot better than the other fiberboard.
These look almost like foam bricks.
Yeah, this other stuff looked more like, it had the consistency of styrofoam. I don't know. I've seen these, Chris. I'm not sure if that's what they are. I'll go ahead and, okay, I've saved it, but I need to talk to Lauren about his and say it didn't seem fibrous. It was more like foam, like a ceramic foam. It was rigid. It seemed to have a cell structure instead of a fiber structure, and could easily be cut into shapes that were rigid and didn't do a bad job. Say the fiberboard I got before, the 2 sides like to peel apart. Right in the middle, the fiber didn't seem to be attached too well. So I'm not sure, but yeah, I'm sure there's something out there. No, it's a white ceramic fiber. It's just kind of a mat that's pressed together with some kind of a binder that didn't really work that great as far as I was concerned. But okay, now he sent me another one. Let's see what we got here. Chris is real good at tracking stuff down this ring. Insulating soft fire brick. This might work, Chris. The stuff I saw, what Lauren had was sheets. I'll go ahead and save this one too. And we shall see. Yeah, I like that idea, Lars. I also really think that any decent furnace worth its salt has to have a replaceable bottom liner. Okay. Those ones I made where, again, I just kind of skim coated the, say it was a thin fiberboard. It was, I think, 1/4 inch. But anyhow, I skim coated it with Satanite. First of all, I'd go thicker than a skim coat if I had my Drozers nowadays, because spilled slag can actually kind of soak through the porosity of the Satanite and get to the fiberboard and dissolve it. But if you get thicker Satanite, it seems to hold it back. By the way, little one, are your crucibles trying to stick to the bottom of your furnace right now? Because there is a puddle in the bottom of your thing.
Yeah, there was a puddle of lead from a Q-Pel that had reached saturation.
Okay.
My crucibles were not sticking to it yet because I haven't put any crucibles in since then.
Okay. I'm not sure what I think we can just scatter a little bit of Portland cement on it to keep it from sticking if necessary.
Yeah.
But anyhow, as an inexpensive, easily swapped out bottom liner with a little lip around the edge, in my opinion, is critical for something that's going to really be used. If you're just using it occasionally, you might be able to get away with it. But in the long run, you're going to make a mess. It's going to destroy your insulation. Life will suck. Have some kind of a catch tray there. Huge, huge improvement. Oh, now let's see what we got here. Okay, iron dung forge. What type of kiln are you using now? It's a tabletop kiln. It's a 110 volt, 13 amp. And it's a little thing about this big. They're small. They're not industrial strength. Castilite 30, castable refractory. Let's see, 5-pound bag, $15. Oh yeah, that's excellent. That's is that, you know, if that's fiber reinforced? Stanza for large lining of forge, floor casting a whole forge. Don't know, but yeah, that looks better than the Satanite. Chris?
I will say that tabletop furnace may not be industrial strength, but considering how badly we've abused it, it's really doing rather well.
How would a ceramic tray work? Okay, this is a problem it's a real common problem, Ricky. The fluxes that you are mixing are designed to dissolve rock when they're at high temperature. They melt and dissolve rock. Most of the linings of kilns are essentially rock. And, but so many of these lining materials they use for kilns, I know the ceramic fiber stuff we've used, the stuff that came with the kiln, you spill some slag on it and it eats it up, literally.
And do save the stuff that gets eaten because you can recover the metal in it.
But I mean, it will just chew it up. I had one crucible that just had a little bit of slag on the side at the top there, and I didn't get it quite enough inside the kiln. And so it touched the fiber insulation on the door, ate a hole in it that big. Okay. And so you spill slag on the bottom, it'll just eat its way right through the floor of your furnace, all kinds of things. So you need some kind of a protective coating to keep that from happening.
What I want, if anyone can find one, the high temperature porcelain material that they make some crucibles out of will withstand slag. And I'm wondering if they make trays of the same material.
Yeah. Well, they also have to be thermal shock resistant and stuff. But yeah, if you could get the equivalent of a Corelle dish, you know, like a square Corelle dish with just little lips on the side and flat on the bottom out of a high temperature ceramic that you can stick in there and it'll take 2,500 degrees without softening and can withstand the corrosive effects of the slag, that would be great. But yeah, slag destroys kilns. It's really, really bad stuff. It will eat through your crucibles over time, depending upon exactly what kind of slag you're using. If you're using a lot of soda ash or, Lord protect you, fluorite as part of it. I have tried tile. They tend to crack. And yes, ceramic tiles, it was a nice idea, but they crack. And that's what I meant by the thermal shock. They're not reinforced. They don't have, you know, like as Chris was talking, you know, aluminum or zirconia fibers that, you know, you can, you know, they're not in your standard floor tile because they're not needed in a standard floor tile. But yeah, I tried that. and it works until it cracks. Once it cracks, slag just goes right through the crack, and there goes the bottom of your kiln. So I took a ceramic fiberboard and skim coated it with a castable ceramic. That seems to have done pretty well in general. Okay. It's also relatively inexpensive. You're talking, I don't know, less than $5 each. Not bad at all. And by making several, when you're doing it, then you can just switch them out. One gets a mess on it, you can take it out, put another one in, and you're back in business real quick. Really important if you're doing the kind of serious stuff like we are, especially with a kiln that's really not built for it. Yeah, you need all the protection you can get. The other thing when you're using an electric kiln, uh, contamination on the coils can cause hot spots, which can cause big problems. Your elements will go quickly. Um, this particular furnace was not designed for quick, repeatable element changeouts. Okay. I mean, it was, had staples in, and again, the material isn't that tough. So pretty quick, you couldn't get a staple to stick and things like that. So we just had to kind of redo the whole furnace. Now by having shelves with the elements laying horizontally where gravity just lays them there, that's working much better. Um, Last time I had to replace an element, what did it take me? Less than 30 minutes?
Yeah.
Yeah, once the kiln's cold, it took me about 30 minutes because I had just shelled. Basically, you got to, stretch and kind of form the element, where the corners are and, this, that, and the other, and stick it in there, and voila. One thing I don't like about this kiln is it does not have ceramic insulators where the wires come through the metal case. And they're uninsulated. They can't be. They're just bare wires that glow yellow hot. So if they had ceramic insulators there, that would be a lot nicer. Originally, all they do is punch a little hole in the thing, and that works fine until things get all worn out, torn up, and this and that and the other. It's not a very durable solution to the problem. So those are some of the places where I would put special focus on in building a kiln. The other thing is when you're roasting resin, that I've seen ceramic, they're like grommets, it shouldn't be too hard to get. But when you're roasting the resin and breaking it down, it creates a lot of smoke. The smoke creates soot. The soot gets on the wires and causes the wires to overheat and fail. If you have spatter of slag, that slag gets on the wire, it's wrapped around the wire, and it causes a hot spot because the heat can't get out of the wire as easily. So you get another failure. Replacing the elements, I think it's less than $5 worth of wire. It didn't seem to make a difference. I kind of prefer the unglazed side simply because it'll tend to catch stuff and keep it from running off to the side and down. You don't want it to get off to the side. As a matter of fact, I took a grinder and actually kind of ground down a little bit so that there was a depression in the middle with a ridge around the edge. Again, so when slag hits, it can spread, but it can't run over the edge very well. But smelting, just ashing the resin is a problem because of the smoke and the soot. Okay, Ricky. I could tell you if you just had an insulator that went from a 1/2 inch diameter at the bottom to 1 inch at the top, fairly short, or you could just step it too. Like this. With a hole in it. And that hole could just be 1/8 of an inch in the middle, just to straighten. And then that 1/2 inch thing will fit in the hole in the metal. The other stuff, you can have extra, it won't matter. And say it's just an electrical insulator. It's to keep the wire from touching the case, because those are bare wires. Another thing that can get you, and this is one reason why you have to change your procedures, which we have. When you're reaching into grabbing stuff inside the kiln, for obvious reasons, you're not using plastic utensils. You're not using electrically insulated utensils, because the insulation will burst into flame. You have to use metal. Okay, think a second here. Live wires all the way around, metal utensil. You can see what's going to happen here sooner or later, right? And so if you accidentally short those two things, your natural reaction is to go, like this. They have welded themselves to your utensil. It's an instantaneous spot weld, basically. So when you do that, those glowing yellow hot wires just stretch. And now you've totally messed up your heating element. Time for significant repairs or replacement. It can be a real pain. So what we've done is change the procedure. Before you reach into the kiln, make sure the power's off. It's not so much a safety issue as you don't want to destroy the damn elements. Because you're already wearing a big leather glove and things like that. The radiant heat is amazing. If you try and do it with a bare hand, just to go in and grab a crucible, the radiant heat will cook,
My heavy
bad.
welding cowhide gloves start smoking sometimes.
Yeah. I say. A power line in general doesn't put out much because it's big enough that the resistance to the amperage and everything, you don't want to generate heat in a power line. These wires are specifically designed to have a certain amount of resistance in them. This is nichrome, not copper. And so it's designed to do exactly that. A safety switch on the door. Well, that would work. It works good enough for this little furnace, Chris. I agree with you that, you'd need better gloves if you were, spending a lot of time. But the welding gloves work okay for the little small furnace we're using, and for the little times that you're close enough where it's really important. We haven't had any problems without the glove. The first time I tried to reach in, it was bad. It's like, yo, that was pretty warm. But anyhow, so ashing resin will probably be best done in a covered crucible in a gas kiln. And part of that is as the nasty gases that are generated from the ashing, as they work their way out of that crucible, they're going to get incinerated by the flame from the kiln too. So that would be a good thing. Anyhow, when it comes to elution, we have made kind of a breakthrough here. Now, in the elution solution testing, we have stuff like, let's see, the difference between the fire assay of the resin before elution and fire assay of the resin after the elution was an assumption that, okay, that was going into solution. It could just be sample variability to some extent. We got one that dropped 14%, another one 13.5%, another one 17%, another one 15%, another one 15%. Then the latest one we tried, and by the way, all those solutions, I think the best 114 parts per million was the best we got, I think.
135.
135 was the best we got until this latest one. 1123, not 123, 1123. Now, we used 500 cc's, or there about 500 grams of solution. We used 50 grams of resin. The 50 grams of resin fire assayed at about 41,000 parts per million. And so you dilute that 10 to 1, and you get about 4,000. So this 1123 meant 27% of the gold got out of the resin into the solution in 3 hours. Okay, which is far and away better than anything we've done before. It's 10 times any solution concentration we've seen before. So we're really stoked about that. However, the testing I've done, don't have a video up on it. I got the video, I got the raw footage in actually it's in the computer now, but I haven't had time to edit it. I just got back today. I went out this morning, did some more work, but the idea was use that electrolytic cell and recirculate the solution through the resin, blah, blah, blah. Well, the problem with that is that particular cell doesn't have a way set up to heat it. And this solution, the manufacturer said, what was it, 135 degrees centigrade? I mean, Fahrenheit, I believe it was 50 degrees or 55 centigrade, something like that. Not real hot. Hotter than a hot tub, but, nowhere near boiling. So my plan tomorrow is to go back out there. So we have that little hot plate. So start with a hot plate and a glass beaker, and hang the steel wool on one side, hang an anode on the other side, put the resin in the bottom with a stirrer, turn on the heat, and apply the current. There's no pump recirculating it, but with this stirrer going, I think that should be good enough. And if that works, say right now we're trying to get the chemistry to work. Okay, we can get the chemistry to work, then we change the system to where we can do a lot more. The plan would be to have a system that's set up so that you just take a resin cartridge out of the loading circuit, put it into the stripping circuit, flip the switch, and come back tomorrow, and it's all stripped and all the gold is on your steel wool. That's the plan. If we can get the right chemistry, I don't see any reason we can't make it work.
Well, I do think we need a different anode, so we're not plating stuff from the anode onto the steel wool.
Well, we may have to go with carbon anodes. We did have a situation where on my first test of the electrolytic cell, Eva smelted the steel wool residue and came up with this little bead. It wasn't real tiny. It was what, 400ths of a gram?
Yeah, it was 0.044 and bright white silver, not silver,
Yeah.
but more like platinum silver or something.
Carbon or lead oxide. Yeah, Chris. Hey, I got some small diameter, I think they were 5 millimeters, something. I don't know. Basically like 1/4 inch rods. When I tried using them as anodes, they kind of started disintegrating, Chris. Is that because they're not the 99.5% carbon rods? Do you know what it was? I mean, they were just cheap, and I didn't realize there's, different quality carbon rod things. But is that what I need to do, is get some carbon rods that are like, some I see are saying 99.5% carbon electrode rods. And I'm not sure, but I mean, they started kind of disassociating and wind up with black carbon floating around and everything. That was highly undesirable. Although better than this other bead we came up, and it's like this bright silvery bead. It won't part. Yeah, I think some are a lot better formed than others, Chris. I'm not sure. They're not terribly expensive. But anyhow, whatever this white metal was, it didn't cupel off. It didn't dissolve well in nitric acid. It was really bright and silvery, and it didn't seem to dissolve with the gold. The gold seemed to be separate from this other metal. So we think what we did was we wound up, and I looked at it and it is eroded. The anode is stainless steel, which consists of things like chromium, nickel, things like these are white, pretty chemically resistant metals and stuff. I think that's what we did. We plated some of the uh, material off the stainless steel rods, which is undesirable. Now it's kind of hard to get away from the gold. Um, I'm not sure, but I would think we could probably reflux it with something and dissolve that, but it'd be better not to have to do it in the first place. I have carbon rods out at the ranch that I should be getting. Let me double check my list here. Should be on here. Warmer, lime, empty stock bottles, vacuum cleaner, carbon rods. Make sure I pick those up too. Yeah. So theoretically, Jim will go out with me Wednesday morning and we'll put that door on at the ranch and get some stuff too. Iron anode only. Pure iron. How about a bolt? The things I have are designed for 5/16ths. So I could go like 5/16ths, what do you call it? Mild steel rod. So come on, Lars. Uh, Hi, Tricky. Well, let's see. Tricky and Chris. Will mild steel work okay? Because I know that would, at least the flux would deal with that okay. I mean, if they corrode, I can replace them. It's pretty easy to do. Still waiting for a response. Is mild steel acceptable? Tricky says yes. Okay. I'll go with mild steel then. Okay. Yeah. Instead of a bolt, yeah, I can just buy like 5/16ths rod and go chink, chink, chink. Shouldn't be a problem. We can also have um, Lauren just take a sheet of something and plasma cut a shape and hang it, something like that. Shouldn't be too hard. Anyhow, yeah. So just sacrifice the damn anodes, huh? I hate that part. I hate having to make more, but you do what you got to do. No, the galvanized zinc is not a good thing. It's a pain in the butt. Rusty bolts, yeah, when they don't have plating on them. Plating can make things difficult. So anyhow, that's my basic plan there. And let's see, I know I've got some sheet steel too out there at the ranch. Let me write that, sheet steel. So let's say we've got some of that lead sheet for assaying, Chris. How do we turn that into lead oxide? You know, what's the methodology for taking that nice, thin, flexible lead sheet and coating it with lead oxide? Mysterious B Choice has the protocol to plate lead oxide on titanium. Mysterious B Choice? Because we got the titanium. Mysterious B Choice. Yeah, Boyce. Bhoice. That's spelled properly, Chris? And is that a website or is that YouTube? Lead citrate, huh? Okay, is that um, YouTube? Okay, YouTube lead oxide on titanium. Okay, we can do that too. He's the cat boy chemist. It will plate on the negative, Paul. The positive likes to disintegrate, and the metals plate on the negative, not both. That's also why, if you're going to be turning off the current, you need to pull the cathode out. Rinse the chemicals off and just put it aside. Because once you turn the current off, if you got anything in there that'll dissolve gold, it'll start just pulling it right back off of the cathode. You need to keep the power on at all times that it's inserted when you've got gold on it. But probably tomorrow we'll work up some kind of a just carbon steel, just mild steel anode for this test. That's easy enough to do. I'm sure we can find some scrap of something over there. Yeah, Chris. Well, we'll be direct electrowinning out of the stripping solution. um, the whole idea of the resin is to take the solution from, this year we've been getting what? Hardly ever got over 10 parts per million, right?
Yeah.
To over 1,000 parts per million. That's why you use the resin. We just can't electroplate out of 10 part per million with low conductivity. There's too much solution we have to treat, etc. With this, well, my evil plan for the thing where we're doing whole cartridges, you'd be using probably like 3 to 4 gallons of solution recycled to treat 330 grams of resin, which is 330 times 0.41 divide by air clear 25. About 5 grams of gold in a batch. In order to do that at 10 parts per million, instead of 4 gallons of solution, you would need, and that'd be 10 parts per million, 10 grams per metric ton. You'd have to do 120 gallons of solution, somewhere around there. That's the whole purpose of the resin thing. You can move that leach solution really quickly through the resin and then deal with the resin later. Right now, for example, it's cold. We couldn't leach anything. We couldn't be direct electrowinning out of our solution because it's been a block. The whole pond's been a block of ice for a month. However, we can do stuff with this. So that's one of the things. Also, theoretically, if you get a good elution methodology, you can reuse the resin. If you're ashing it, it's just a direct cost, but nevertheless, spending $1 to make 100 is, I'll do that all day long. So that's the evil plan. This is what the solution looked like after electroplating. It lost quite a bit of color, and taking that to the lab tomorrow so that they can tell me if there's anything left in the solution or whether I'm not an electrochemist, so I'm just kind of, driving by braille here. You hit the rumble strips and correct. So I double check and make sure that I am electrowinning the gold out of solution. Tonight, the low is 21. Not sure what it is here. It may not even be that cold here. Let's see. It's really getting the Pineapple Express here. Let's see. Tonight,
it's the Chinook winds.
39 degrees for a low. Tomorrow, high 44, low 34. Wednesday, high 37, low 22. Then we're back in the highs near freezing and the lows in the teens for the foreseeable future. Not too bad. Yeah, Rob. Yeah, I have to rev the engine a little bit to get it to start. I think you pretty much have to neutralize any remaining Eco Gold X before you precipitate, but I don't know, Lars. We didn't get it to work. Yeah. So we tried just a simple granular zinc in a cartridge just to see what would happen. It didn't seem to work too well. So we'll just let that slide for now. So I'm really not sure, Tricky.
Well, my question on that there is,
What?
if we could come up with some more 1100 parts per million solution, maybe the zinc would work better in that, since it's a higher concentration. Just saying.
Could we just cement the gold out of the elution solution, guys? What do you think? Say, I don't know the electrochemistry of it. If we can get it back into that solution without it redissolving when you try to precipitate it. Well, if you can completely avoid the electroplating, perhaps just direct cementation would work fine. I agree with Chris. If you use just the right voltage, you can control things pretty well. But we're talking in single digits and fractional volts. We're not talking anything over 10 volts here in general. On a larger cell, you might need that just to overcome the resistance in the between the plates and stuff like that. But we're getting plenty of amps for what we're doing. How many amps do we need to plate 1 ounce of gold, Chris? That's a question. You know how to do that calculation. How many coulombs of electrons does it take? And how many amps is that? Amp hours, I guess. Yeah, when you're talking electroplating, assuming it's doing relatively efficiently, it's directly proportional to how many electrons are moving. So you're talking about amp hours, though it's quite often measured in coulombs, COLOUMB, I believe. Okay, Chris. Moles per ounce. Good question. How many moles per ounce of gold? Boy, my eyes are horrible. $196 197 is the atomic weight. Yeah, 197 is the atomic weight, Chris. Ugh. So let me see. You do your well. 197 divided by 31. About 6 moles per ounce, I believe. Coulombs per second. Yeah, probably. Say it'll relate directly to amp hours. Yeah, if you're trying to transmit it, that's how you would do it. High voltage, low amperage. When you're trying to plate, the amperage is what matters. You know, the voltage, anything over so much is worse than a waste. Okay. You just want that many amps, but the effective amp hours, you might call it, how much can actually be applied effectively to the thing is what matters. Hello, Mix. So say I'm kind of thinking I'm thinking probably a couple of amps for 6 or 12 hours should be enough to plate out an entire ounce. And so we're looking at things like, a quarter to a fifth of an ounce per batch. So you can see the amps isn't that much. But okay, 10 to the fourth coulombs per mole. Okay, how many amp hours is that, Chris? My power supply is not rated in coulombs.
What is a coulomb?
It's a number of electrons. I mean, it's like, the equivalent of moles.
Okay.
Okay, it's a whole bunch of electrons.
This is new math. It can go away.
1.06 volt max, or you will plate out other stuff, but you need good and tuck to, you can add sodium bicarbonate or something. I've got about 10% battery acid. That seems to work pretty good. 1.06 volts. Now, when we're talking 1.06 volts, that doesn't take into account 1 amp for 1 second is 1 coulomb. Okay, so 10 times 10 to the fourth. So that would be 100,000 coulombs divided by, what was it, 197 divided by 31, call it 6. So you're talking 100,000 divided by 6, and these are just rough numbers. 16,000 seconds. Okay. Divided by 60 is 277 amp minutes. Divided by 60. 4.6 amp hours is what I'm getting. So let's say it doesn't take that much to play, and that's for a whole ounce of gold. So, for what I'm needing, about 1 amp hour should do what I need to do. And I'm pulling, well, that last test I did, I was pulling 0.45 amps. So again, that's not the real issue. The real issue is trying to get the right chemistry and not to get too many volts. So you plate other stuff too. You're trying to get that sweet spot where you're plating the gold and nothing else if you can do it. Yeah, Trey. And oh, here's another good question. What's the solubility of thiourea? I'm going to look that up right now. Solubility of thiourea. Because it doesn't seem to be 26 grams per liter at room temperature. Yeah, that's why I'm having trouble. Well, that's thiourea dioxide. I'm not talking about thiourea dioxide. Uh, oh my goodness. Thiourea and overdose. What's the solubility of thiourea in water? And it's going to give me 256,427. Okay. 137 grams per liter. Yeah. Okay. So the solubility of thiourea. That's why I'm having problems. 137 grams per liter at 20C. Okay. Yeah. That's why I'm having issues, is because I'm trying to get a pretty strong solution of thiourea. It makes it a little hard. Yeah, I'm so far our anodes aren't showing much erosion, Tricky. The stainless steel's holding up pretty good, but with that mild steel, I imagine it's going to start getting chewed up pretty good too. Not sure how much passivation will happen. That's another question. Quite often, as you do these kind of reactions, the electrode gets covered with something. The anode can get covered with some of this non-conductive, and then you got problems. It's called passivation. But anyhow, say that's the test I'm going to be doing tomorrow. I'll go ahead and use a mild steel anode on that one, guys, and we'll see what happens. But that was a real interesting. That was a very pretty little bead. For a minute there, we thought we might have platinum group metals, but then I realized, nah, we got some white, shiny, not terribly reactive stuff in that stainless steel. The hydrated oxides expand and flake off. Yeah, it's kind of a porous coating. It has to be a pretty tight, impermeable coating to really passivate well. So yeah, I'll try just a mild steel electrode tomorrow and see what we come up with. Oh, shouldn't be too tough. I'm sure he can find some mild steel around his place. Thank you, Tricky. Um, what makes 2 or 3 amps, Paul? Coulomb, huh? I'm glad you used the progressive there and the adjective there, Lars. Makes sense. Coulomb, okay, because he was cool. Some French dude, long time ago. You know how it goes, like Lavoisier. Did I? I think I got that one right, Lars. Let me know if I'm wrong. But so that's what we're doing right now. And I say I can't thank Eve enough for all the work she's been doing, even with her messed up back. Oh, but she seems to enjoy it. Your pancake coil, Tesla coil, yeah, yeah. It doesn't take a lot of amps when you got high voltage. Say 2 or 3 amps. At high voltage, that's enough to fry your butt. Uh, yeah, Lavoisier and Eva would get along just fine. She wants to weigh everything, you know? So we're going to test, we're going to fire the furnace, um, the residue from the steel wool that was running over the weekend, and we'll get a good idea of what we got there. And that's going to be interesting. But yeah, I like the idea of using, even if it's a sacrificial steel anode, as long as it doesn't get things like chromium and nickel into the bead, which are real hard to get out of the bead. you know, it's one of those things that's not too good. Yeah, I agree, Paul. I like Van de Graaff generators for that reason. It's real impressive, only mildly painful, certainly not dangerous. Oh, and since again I'm left without my sidekick or whatever he wants to call himself, Jim. He's again, somebody has a birthday today he was at, so we're left again without Jim. But I'll say I'm trying to do the best I can. Oh man, all in all, it's better than trying to fix pipes at 1 o'clock in the morning when it's 30 below zero outside. That was less than fun. I'm glad about the no traps, Tricky. You be real careful. Okay? You got a wife and kiddies that need you. So I understand the excitement and stuff. Just be careful. Not suggesting you don't. Just be careful. We want to hear from you next week. Oh goodness. Oh. Oh my goodness. Did you call your doctor today?
No, I did not. I will have to call my doctor tomorrow morning.
Call Eva doctor back. Yep. So, yeah, we got to find out what's going on with Eva's back. That takes a specialist. And we haven't heard from the specialist yet.
Well, it is the holiday season,
So, we'll have to see what's happening. Yeah, Paul. What I find is really amazing is those guys that do the service work on the high tension lines. They just fly up to a helicopter and, charge the helicopter to the line voltage and then step across. That's just amazing. Yeah, I'm only in a chainmail suit with a 500,000 volt charge on it, but hey, I'm not shorting the ground. It doesn't matter. Wow, that's some bizarre stuff, man. I don't know which would be scarier, the electricity or the 100 feet to the ground thingy. For someone like me, I'm not happy at high elevations. Don't mind flying. Don't like, you see me hanging from ropes. Yeah, in some situations, it's very stressful on me. Especially the first time I'm going down somewhere. I'm not sure what's ahead of me. That gets a little weird. I would imagine, Shaggy, one way or the other. Um, I suppose if you fall, at least you get some excitement before you go whack. If you get shocked, it's so fast you'll never notice it. Yeah, pluses and minuses, pluses and minuses. I like declines, Chris. I don't like going down a shaft where there's nothing underneath me. But with a decline where you're just going down a slope, to me, that's a lot more comfortable because you're standing on something and just lowering yourself with the rope. Yeah, that's not nearly as bad for me. I don't like brows. Going over a brow, yeah, that can get going down is easy. It's the coming up part that's shall we say a bit challenging at times. Yeah. I remember one time I was going over an ore chute and I wound up hanging upside down about 2 feet from the ground and I couldn't get to it, you know? And so I had to, basically grab the rope and pull myself back up into the ore chute and get things rearranged a bit. But yeah, that was a very uncomfortable uh, feeling to just be hanging there going, I can't touch the ground. And I can't get my Jumars or anything down the rope. "300-foot grain elevator." That's a lot of height. Yep. Back in the day. It's been a long time, but we just have to live with it. Anyhow, okay, I'm better now. By the way, we watched a couple movies last night. One is called The Ultimate Gift, and hello, Adam, and it is quite the tearjerker. Very well done. I recommend the movie. Make sure you got plenty of Kleenex. So it was well done, but yeah, you're gonna leak if you have a heart. I know some of you guys probably don't. Lars would probably laugh. Ha ha. But anyhow, so gosh, that's about it in terms of progress. It's been a bad week because of the weather, you know. Um, yeah, that 30 below zero stuff, you just can't get a whole lot done. Good idea, Adam. Yeah. Try and get a description. It's amazing how we're not hearing anything to speak of about this, huh? Our infrastructure is literally under attack. No big deal.
You've got to kill another 12 minutes, dude.
I got to kill another. The boss says I got to kill another 12 minutes.
The goddess has spoken.
Ah. Yeah. So, anyhow, yeah, I got to figure out what's the best voltage on the cell, and that has to do with things like just the spacing of that too, because the resistance, it requires a certain amount of voltage just to overcome the resistance, the exact solution concentrations and stuff. So exactly where do you want to set it gets a little bit nebulous at times, and that would be if a guy really knew what he was doing, which I don't. So yeah, and so it's going to be a lot of testing. Yeah, it is a crazy situation. Yeah, Paul, I agree. Letting yourself down backwards. Yeah, because, can you get back up? There's this cave over in South Africa where they found a whole bunch of hominid fossils. And I mean, all the cavers have to be like less than 5 feet tall because there's times where they're squeezing through things like 10 inches wide. And they have to take the hard hat off because it's too wide to go through the crack.
Their lead caver was a 4'10" chick, tinier than me.
Well, I understand, and I do have a constant current setting, but I don't know how to run a constant current setting. I'm not sure how uh, to do that. And as the ions get depleted, I believe the current should kind of bleed off. I mean, you should be getting less and less current flows. You have less and less things to plate, but I don't know. Thank you very much, Tricky. Yeah, Lars, if you know what amperage to set, that'd be fine, because the power supply does have a constant voltage or constant amperage setting. Chris says we need to control both the current and the voltage in a complex cell. Oh dear, that sounds like a lot of control, Chris. I'm not sure I can handle that. I don't know if I can keep it together, Captain. But anyhow, she's not going to take much more of this. No, it's just an electrolytic cell, Adam. Yeah, I think to start with, I'll just go for trying to figure out what voltage I need. Once I figure out how many amps the voltage I need gives me, then I might be able to go with the constant amperage thing, but I don't know. I also think it'd probably be a lot different if you were constantly monitoring it. But if it's something that you're turning it on and coming back tomorrow, I'm thinking probably the constant voltage would be a better option for that situation. Don't know. Again, I'm no expert in this crap. Yeah, I know what you're saying, Lars. Constant current, and it will adjust the voltage to keep the current constant. But as you plate all the ions out of solution, in order to keep that constant current, it's got to keep jumping and jumping and jumping the voltage. And now you start plating other ions, and that's where I say this is not a simple electroplating cell where you got lots of ions and an anode that's being dissolved as other stuff's being plated. You got a mix of ions, Oh, I say I've got a fancier power supply than I can use. I don't know how to use near these options. I don't think it has waveforms, though. I think it's basically just straight DC. I don't know if it's pulse DC or not, but I say it's definitely got constant current versus constant voltage. I know that setting. I know where the button is. Oh, and of course, it's not the most expensive power supply in God's green earth either. So, it doesn't have all the bezels. I probably will eventually, Lars. I say, but it's one of those things I can probably just do it once I've built the final cartridge stripping apparatus. It should be pretty much a just put the cartridge in, turn the, make sure the solution's at temperature, turn the pump on, turn the electrolytic cell on, and it's like, it goes. That's the idea. If we can get it that simple, I don't see why it can't get that simple. But then, and okay, Chris. Yeah, Chris says it can do pulse DC, but you'd have to have a computer hooked to it. That sounds about right. Damn electrons. Herding those things is just so much trouble. Oh. Oh, okay, that's what it is. I'm looking at a timer there and a clock here. That's why it looks differently. Do you know how the different energy levels of gold work? Roughly, Adam. In this case, it's more the electrochemical series, I believe. It has an RS-485 interface. Whatever an RS-485 interface is. Sounds special. In the electrochemical series, it's pretty much certain voltages do certain things, especially between certain metals and blah, blah, blah. But I don't think it's gets down too much to energy levels, but I'm not sure. It's getting ready to hit him again, Argonaut. If you're in the area, he could probably use some help sandbagging. Man. Most people just have mine doors. Your needs gaskets. You know. Have you considered going to the Navy where they're scrapping a ship and getting one of those bulkhead doors? But do you need different voltages, Chris, when you're dealing with different valence states in solution? Or will the same voltage plate out the same ion? I could see where it would change the number of electrons, and therefore the amp hours needed. But you have different. Are they significantly different or just mildly different, Chris? Yeah, I think that's what you need. You need one of those, just put in a big steel frame and concrete on the sides and with a gasket. Yep. Yeah, that's a real pain, Lars. But yeah, short of, and even if you change the downstream slope, it'll tend to return to the previous slope. You need to pulse the DC with a triangle waveform to extract gold directly from the resin. Interesting, Tricky.
A triangle waveform?
That's what he said. Let's see. Looking tricky. Tink-a-tink, tink-a-tink, ka-chink. Computer's working tricky. Going through the steps. Sign in, click, 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 click. Electrowinning from dilute cyanide solutions. Okay, direct electrowinning. Let's see, and there it is. How many pages is this? Gold electrowinning from diluted cyanide liquors, performance evaluation of different reaction systems. 24 citations. Let's see, Center for Mineral Technology, Rio de Janeiro. Well, it doesn't have thing there. What's the last page? Oh my goodness. I hate it when it does that. Page, those are citations or something. Oh, good Lord. Let's see how many pages it says on the print option. Total 7 sheets of paper. I'll go ahead and do that. Total 7 sheets of paper. Pages all. Okay. Okay, it's printing. Or it should be printing. Takes a minute. Let's see if it translates. Well, was that in? Oh, this is The title's in English. Heat bleaching with cyanide solutions. Yeah. Okay. Chris, that's presumed confounding factor. Until we finally figure out what it is, it's a presumed confounding factor. Lars, that sounds complicated. Lars says, I'd try a modified square wave with a DC offset and 20% AC noise.
A modified what?
Coming up here, give it a shot, man.
Excuse me.
You're welcome to give it a try.
We're like curvy things. What's all this triangle and square things here?
Well, a square wave, you're plotting voltage against time, right? Now you could have a pulse DC, which would be 0, 0, 0, 2, 2, 2, 0, 0, 0, 2, 2, 2. That's a square wave DC. It's pulsing on and off, basically. But it goes instantly on, goes for a certain period of time, instantly off, and like that. You could have a square wave AC, where it's like -2, -2, -2, +2, +2, +2, -2, -2, -2, +2, like that. A sine wave is the one that's curvy because the voltage is changing at all times. It's never steady.
So what's with this triangle shit? Where did the triangle?
You like that? I think that's called a sawtooth also. Don't forget the flux capacitor. I'm sure I would have had them, and but I mean, you can have.
Well, you do realize that a flux capacitor does you no good without a DeLorean. Come on now, people.
Can't use like a Ferrari?
No.
No? Oh, okay.
You gotta have a DeLorean.
Does my electricity go 1,000 feet? No. It goes about a foot, 2. Tricky says, to pull from the resin, you need 20-volt DC with a 10-volt sawtooth. And Lars goes, Argonaut said a full GERD rectifier. I'm sure he meant grid. Rectifier bridge. And Lars goes, rectum fryer?
Y'all do realize you're getting a little complicated here.
Yes, we know we're getting a little complicated. That's the problem. If it was simple, we would have had it figured out already. That's the problem. Okay, printed both sides. Good. There we go. Okay, stapler. Thank you, Tricky. Appreciate it. I'll read that mañana. Lars says the flux capacitor will work on our minor Bago if you get it up to 140 miles an hour. That would probably take a Chinook and about 2,000 feet. Although I wouldn't be surprised if the terminal velocity was less than that. Oh, my goodness. Oh. So yeah, it gets a little complicated in theory. Once you figure out exactly what to do, the practice gets pretty simple. It's like a car. It's real complicated to design and build, not nearly so hard to drive. The owner's manual is a lot simpler than the design plans, which are also a lot simpler than what it took to get to the design plans. So that's what we're trying to do here. So that's the basic idea, is come up with something that's fairly simple. I'm hoping that I can come up with something that will be pretty simple and straightforward to put together, and also can basically be broken down and put into the secondary containment tote for transport easily enough. So it should make like a kit, you know, in a medium-sized tote. Not one of the big giant ones, but not a small one either, but a medium-sized one. Has all the parts you need. You can set it up and make it work.
I will be over there in a minute. I'm talking to somebody about something important here.
Oh, it's now up to 3, huh? Sweet, Adam. Yeah, you just punch in microfine gold and see what you get. Like I did it on Bing, and I think like 8 or 9 of the top 20 were me. Oh, yeah, that was what was it, a couple years ago we found out, well, let's just search, where does gold come? I was like 8 or something like that on Google, and I'm like, wow, that's amazing. Tricky, if you're going to do that, visit Eva. She'll be able to have a nice conversation. She'll translate and let me know, okay? Yeah, you don't have to worry about the vax or nothing that way, Tricky. Just be careful, okay? We don't want to have to do that, okay? That's right. Do as you're told, young man. Some guy was trying to tell me this week that I needed to buy an electric truck. It was so funny. He was trying to, I said, well, I do a lot of this off-road and towing trailers on, well, you need to get, I think it was a Tesla. I'm not sure what it was, but, 4-wheel drive, it's got a range of 500 miles and it's only got a 10% power loss in the lower temperature. I'm thinking, I don't think 30 below is a 10% power loss. I bet you it's a lot worse than that. But you know what shut him up? I said, hey, look, if you want to give me one and pay for the gift taxes on top of it, I'll be happy to take it. Haven't heard anything since. I can't imagine what one of those things would cost, but I mean, I'm on Social Security. I'm not rich. What am I supposed to do? I would imagine something like that's got to be in the $150,000 range.
Oh yeah, the Ford Lightning, the price has gone up 40% in the last year.
Yeah, I don't know. I mean, what's the Tesla truck thing? Whatever. And by the way, 500-mile range towing. Yeah, I believe it when I see it. But nevertheless, I say that thing's got to be like 150,000, I would think. And how am I supposed to buy this? I mean, if I had 20,000 to spend on the truck, I'd really fix the one I got up. Have you actually done it, Paul? Okay. So I've talked to people who say, well, I know someone who did it. I know, but I say, you have, huh? Okay. So you're burning water in your car. You're only using water. Yeah, no other external sources of power. Is this correct? Or are you dissociating water and then using that as a fuel, and you're just plugging it into the house power supply or a electric thing? Gas and water, okay. But I say, what is it basically doing? Are you doing water injection, or you electrolyzing the water and using the hydrogen and oxygen? And if you are electrolyzing the water, I mean, a friend of mine said that, his dad had this thing and it was hooked up to the, what do you call it? Alternator and stuff. He had a generator and it would make this. And it's like, the laws of thermodynamics basically say you can't make a generator to run an electric motor that, will keep running. I mean, it's going to have losses. And so if you're electrolyzing water and then using that to push an engine, which is then running a generator, which is electrolyzing the water, you're going to get losses all along the thing. Add hydrogen and oxygen to your gas, and that makes the gas burn more efficiently. Is that what's happening, Paul? Because I say the only place it might help is in the transients upon acceleration. Yeah, I can see what you're saying. Kind of like a hybrid car, where you need that extra burst of power for a short period of time. I think the goddess is getting ready here.
I'm getting ready.
She's getting ready. She's preparing to meet her public. What kind of mileage or performance improvements did you get, Argonaut or Paul? Either one. Let's say I know some guy he's got a solar installation and he uses that to make hydrogen that he then powers his car with. I'll try. Let me write it down here. Paul Coover.
Those things are ecological nightmares.
Okay, so you're getting a more efficient fuel burn, huh? Argonaut didn't see much improvement. Of course, that doesn't mean anything. I mean, it's not proof one way or the other, Paul. I said, what improvements in economy or acceleration or whatever have you quantified, Paul? I say, I know somebody who did that because they were using solar power. You can do the same thing with an electric car. I know some people, we did some work on their house in Tucson. These people had serious money. They covered their house with solar cells, used it. I mean, I think they used the tax deduction to pay for the Tesla, and us poor taxpayers had to pay for rich people to save money on electricity and give them a rebate on their Tesla. I wasn't too happy with that. They seem to be okay people, though. Boy, they had working in the kitchen was kind of nervous. We were working over a really big, really special granite slab counter, and it matched all the other granite slab counters. And this was not normal granite. Break that, it's going to get real pricey real fast.
Oh, you want real pricey? It could have been that labradorite countertop we saw.
Actually, that would have been much easier to fix.
Which I want.
That would have been much easier to fix because that's something
howdy.
They can do. They can build.
Yeah, that stuff is beautiful. If you've never seen it before, there is a company in Tucson called Madagascar Minerals that makes composite labradorite like this.
Not composite. It's just
they make labradorite countertops. We're talking a vibe like you would not believe. I can so picture those in my house. If I ever won the lottery and I ever got a house.
I'm trying, Lars.
Which ain't happening. Howdy, everybody. Hi, Chris. Hi, Lars.
Nothing much I can do. I just run out of... It doesn't matter.
Well, you might want to shift the whole board over.
Well, then you can't
and sit in front of it while you do your
I'm trying to get things lined up for that. That's the whole point.
Well, I hope everyone had a wonderful, wonderful Christmas. I once again watched The Ultimate Gift and cried buckets and went down the checklist at the end of the movie and discovered I had all the ultimate gifts, which means I'm wealthy as fuck compared to most people. Isn't that wonderful? And oh, I got some beautiful stuff at my local coin shop this past week. Yes, silver and gold are still on sale. And hopefully they will continue to be on sale long enough for all of us to back up our trucks here. Yes, Lars, he now has my sign up. Though I do wish there were a better way to put it up. Just saying. But yeah, it was a very good Christmas. We got a very good ham that was reasonably cheap. And I did get those socks in Amazon, the soccer socks. I'm not entirely impressed with these socks, but I will say this. So far, they are holding up. They are not nearly as ugly as they looked in the pictures. In fact, they're almost a Prussian blue color. And when you put other socks over them under your boots, they're warm as hell. So I will say I'm getting used to the scratchy thing going on too. So down there in Panama, First Quantum's CEO is now holding talks with the Panamanian minister over their mine that is being thrown into care and maintenance. The chief executive officer of Canadian miner First Quantum Minerals met Panama's Commerce and Industry Minister on Monday to discuss disagreements, that's one word for them, over the firm's copper operations in the country, a person familiar with the matter said. First Quantum CEO Tristan Pascal flew to Panama over Christmas to attend the meeting in person with the minister, Federico Alfaro, according to the source, who said further talks are planned. The Commerce and Industry Ministry did not immediately reply to a request for comment. A spokesperson for First Quantum declined to comment. The government and the mining company have been discussing a deal that would have increased annual tax payments to Panama to at least $375 million. The Panamanian government ordered the firm to halt operations at the Cobre Panama mine after they both missed a deadline to reach an agreement. The firm started arbitration proceedings against the government days after, according to local authorities. A government official said last week the country was looking for a fair deal. There's that word that governments love so much. Fair. The mine accounts for roughly 3.5% of Panama's gross domestic product, according to government figures. Interesting. Once again, we have a government using the word fair. This is usually bad news. We can only hope that they come to some agreement that is actually fair. I'm not necessarily saying that Panama shouldn't get a little extra money. However, I do not believe that Panama should get a minimum amount every single year, regardless of profit or anything else. That's a little bit, not exactly a good thing outside of lease payments, okay? Just saying. Hi, Shaggy. Copper price rises on the weaker dollar and demand hopes. Yeah, let's hope, okay? Copper price rose on Monday, supported by a weak U.S. dollar and hopes of better demand after China's pledge to boost its economy and real estate sector. Really now? Well, now the goddess is confused. Because the goddess has been watching Chinese state media, the little that you can manage to access outside China. And the goddess has been watching other economic indicators. And China's real estate market still appears to be in a very severe state of meltdown and imminent collapse. So I'm curious as to how they're going to boost their economy and their real estate sector. Copper for delivery in March rose 0.3% on the COMEX market in New York, touching $381 per pound or $8,382 per ton. The most traded January copper contract on the Shanghai Futures Exchange added 0.8% to 66,010 yuan per ton as of 6:14 Greenwich Mean Time. The dollar slid against most currencies on Friday as data signaled the U.S. economy is cooling a bit, reinforcing expectations of smaller interest rate increases from the Federal Reserve and improving investors' risk appetite. I think this is going to fall under the category of if you can't say anything nice. Raising hopes of policy support, a top advisor of the People's Bank of China on Saturday called for strengthening of real estate policy in light of sluggish economic growth over the past several years. Amid a new wave of infections, however, China's National Health Commission said it would stop publishing daily case numbers for the coronavirus, complicating investors' tasks to assess the economic impact. Really now? Okay. Iron ore prices rises as more policy support looms in China. That's good. Rescue work continues after gold mine collapse in China. Gold mine collapses are fairly uncommon compared to coal. Let's see what's going on here. Rescue work continues after 18 people were trapped underground as a gold mine in northwest China's Xinjiang Uyghur Autonomous Region collapsed on Saturday. Approximately 40 people were working underground at the time of the accident in Yingning County on the Iliri Kazakh Autonomous Prefecture. 22 miners have been rescued. Now, the accurate location of the trapped people has been determined. However, the complex situation underground and the unstable surrounding rocks have brought many difficulties to the rescue work. The 18 people remain out of contact. Lu Wei, Chief Safety Officer of Xinjiang Non-Ferrous Metals Industry Group Company Limited, told Xinhua News. The mine is operated by Western Gold Mine. Last September, 19 miners died after the collapse of a coal mine in the Qinghai region. In December 2021, 2 miners died after a coal mine flooded in Shaanxi province. Let's hope they get out. That's about all we can say to that. Yeah. This, by the way, is the color. Note, it is pretty darn close to Prussian blue. So they are not quite as horrifically ugly as the pictures were on Amazon. That's all we can say. Oh, we can say one other thing. The ye old Walmart here locally had only those idiotic looking little footy things that are not in any sane universe socks in stock in the men's department when we were in there the other day. Just so you know.
Men don't wear booty.
The goddess is apparently expected to face the coming collapse of the world economy with inferior socks. And this is entirely unacceptable. We really, really need to get a good sock loom, and I need to get some good sock thread so that I can make socks because this is kind of bullshit. Just saying. And by no stretch of the universe are footies actually socks. I don't even consider them socks for chicks. The fact that they are in the men's department is severely disturbing to my wall and my feng shui and the universe at large. The goddess is highly displeased with the lack of socks in the world. This is totally and completely unacceptable, okay? Plenty of other things are disappearing too, but the socks is going a little far here. Just saying. Oh, and it turns out gold objects were also valued during the Bronze Age. Archaeologists from the University of Leicester and the University of Southampton have identified a 4,000-year-old gold working toolkit amongst the grave goods from an important Bronze Age burial near Stonehenge. The toolkit was found at the Upton level G2A Bronze Age burial, which was excavated in 1801 and is now on display at the Wiltshire Museum in Devizes. Devizes, weird. What the team did is re-examine the stone and copper alloy grave goods found with the burial, revealing they are gold working tools. While carrying out a wear analysis of the grave goods, researcher Christina Soraki noticed what appeared to be gold residue on their surfaces. It also became clear that stone tools had been used for a range of different purposes. Some were used like hammers and anvils, where others had been used to smooth other materials. Soraki's findings prompted the team to look at the residues using a scanning electron microscope coupled to an energy dispersive spectrometer. Great science here. To both confirm this identification and investigate whether the residues were ancient or modern. Their research, published in the journal Antiquity, confirmed gold residues are present on 5 artifacts. These residues are characterized by an elemental signature consistent with Bronze Age gold work found throughout the UK. Previous research had identified possible gold traces on one of the stone grave goods. The new research identified further 4 stone objects with gold on their surfaces and characteristic wear traces, linking a wider suite of items from the burial to the gold working process. It also demonstrates these gold traces are ancient. Thus, the team suggests the tools were used to make multi-material objects where a core object was crafted in a material like jet, shale, amber, wood, or copper, and decorated with a thin layer of gold sheet. Gold working tools dating to the early Bronze Age are extremely rare, so identifying a toolkit for creating composite gold objects is an extremely important discovery, Chris Standish, co-author of the study, said. Coolness. Gotta love this archaeology stuff going on. Paul Coover says it helped his performance drastically. You could cook and eat an egg out of his exhaust pipe clean and higher performance. Cool.
That could help with our car.
Yeah. Well, we could probably cook an egg on an engine block, but I wouldn't want to try it these days.
Exhaust manifold is better.
Meanwhile, over at Kitco, which should probably be named Cryptco at this point, gold right now is sitting at $1805.70 as an ask price. And silver at the moment is at $23.94. Woohoo! So things are looking up in that department. For some bizarre and unaccountable reason, palladium is still falling, rhodium is still falling, platinum is actually looking a little bit kind of sad right now, but lead is at 98 cents a pound. So there are a couple of silver lead mines around here that I might start taking a closer look at. This is looking good in that regard. You never know. Ha! And in the crypto world, Fidelity and HSBC, our favorite criminal money laundering international cartel bank, are the latest financial firms to seek trademarks in the metaverse. Now, in case you missed the news about the metaverse, there has been a settlement in a class action suit that was put out some years ago against Cambridge Analytica, which supposedly is bankrupt, but guess what? They're still out there, just under different names. Spies by any other names still smell like spies and still act like spies. So, way back in the day, we're talking around 2016 here, back when dinos roamed the earth and things were still relatively sane, Cambridge Analytica had people taking a nice, fun little psychiatric quiz, one of those cool little personality quizzes on Facebook. And in the process of taking that cool little personality quiz, they were using the opportunity of burying in the terms of service the fact that they were going to harvest all your data. And they did a hoovering of Facebook's data that basically stole all of it from the United States to be used in the 2016 election. By both sides, by the way. Cambridge Analytica always plays both sides. Well, the British government, for some bizarre and unaccountable reason, took a rather dim view of this, and there was a class action suit mounted by some individuals. And so now here we are for 5-6 years down the pike, Meta, the parent company of Facebook, is now going to be shelling out $750 million with an M. It may be a little more, but it really is a drop in the bucket. There has been no mechanism put forth as of yet for injured parties to get this money from this class action lawsuit or anything else. In the meantime, even though the metaverse has been losing money hand over fist and is cutting employees, we have all kinds of interesting players that are all seeking trademarks in the metaverse space for some bizarre and unaccountable reason. And now Fidelity and HSBC, the very well-known criminal bank cartel, are the latest financial firms to seek trademarks in the metaverse. Fidelity is showing no hesitation when engaging with blockchain technology and cryptocurrencies, as the multi-trillion-dollar asset manager recently filed for 3 U.S. trademark applications to provide services in the metaverse and other virtual worlds. Isn't that wonderful? Licensed trademark attorney Michael Condudes highlighted the trademark applications by Fidelity in a tweet posted Monday, showing the Financial Services Corporation is looking to get involved with NFTs and NFT marketplaces, metaverse investment services, virtual real estate investing, and cryptocurrency trading. A closer look at the graphic that Kokundis included with his tweet shows the trademark applications were filed on December 21st. Also mentions plans to create mutual fund investment services in the metaverse, retirement fund investment services in the metaverse, financial planning in the metaverse, and cryptocurrency payment processing, among other services. Fidelity has been one of the most active financial firms when it comes to engaging with cryptocurrencies and looking for ways to provide access for its clients. In October, the company launched an Ethereum index fund to give clients exposure to Ether. In November, it announced it would be offering commission-free trading of Bitcoin and Ether alongside traditional stock investments on its mobile app. The latest move shows the firm is looking to get ahead of the game regarding services in the metaverse, as it has established the rights to its name and services it will provide once the metaverse is built with a larger community of active participants. Meanwhile, HSBC is also in on this. HSBC has filed trademark applications for its name and logo. The applications were filed on December 15th and also include a variety of plans for services such as digital media backed by NFTs, virtual currency exchange and transfers, and virtual credit card processing. HSBC is also looking to provide financial advisory services in the metaverse and create virtual environments that users can use to interact for recreational, leisure, or entertainment purposes. The filings from HSBC and Fidelity follow moves by several larger financial institutions to establish a presence in the metaverse early on. Yeah. In October, Visa International Service Association filed to trademark its well-known Visa logo so it could be used to view, access, store, monitor, manage, trade, send, receive, transmit, and exchange digital currency, virtual currency, cryptocurrency, digital and blockchain assets, and NFTs. And then in November, the United States Patent and Trademark Office approved JP Morgan's application for the JP Morgan Wallet, which is designed to transfer and exchange virtual currencies, offer crypto payment processing, virtual checking accounts, and financial services in general. So it appears that all of our favorite criminals are foaming at the mouth and waiting impatiently to swoop in to Zuck the Cuck's amazing meta world, the metaverse. You know, the goddess would put put this down as reason 1707 now to assiduously avoid Facebook and the metaverse. Oh no, Homegirl does not play that. Period. End of story. Not going to happen. It's bad enough, all this shit going down in the metaverse. I'm not going to go in there and find out how much worse it's going to get, because it probably will. Inflation could rise beyond 10% in 2023. Wow, really? Fed rate hikes may make it worse, according to Peter Schiff. Inflation, which peaked, according to the Fed, at 9.1% in June, is further to rise in 2023, said Peter Schiff, chief market strategist at Euro Pacific Asset Management, who correctly forecasted the 2008 housing crash and high inflation in 2022. We're not getting anywhere near 2% inflation, he said. Maybe we'll go below 7% before we go above 10%. But I think we're going to take out the highs from 2022 before the end of 2023 on a year-over-year basis. Now, my only question for Mr. Schiff, who, by the way, by and large, is actually a fairly sane individual for a financial type person nowadays, is he calculating by the current CPI formula, by the new and improved CPI formula that's coming out very soon, that's looks like it's going to cut the numbers in half? Because he certainly isn't calculating by the CPI formula that we got rid of in the 80s because it was telling the truth. I mean, just saying, just asking. The Federal Reserve has hiked rates over the year by 425 basis points in an effort to rein in inflation. But Schiff said they could end up making the situation worse. Well, no shit, Sherlock. Rising interest rates actually feed into higher consumer prices. Really now? Who'd have thunk it? If I am a business, I have to pay interest on my debt. Well, if interest rates goes up, that's a cost of doing business. I might have to raise prices to cover that. Well, derp, Mr. Schiff, who'd have thunk it? Schiff, who campaigned for a Senate seat in 2010, said the way to stop inflation would be through fiscal prudence. Oh boy, he's really in trouble now. If we want to stop taxing people through inflation, well, the government considers that a feature, so they don't want to stop it. We have to either tax them another way or we have to cut spending. We have to balance the budget. Oh, they're really not going to like him now. However, he added it's unlikely such a policy would be adopted because it would fail to garner political support. Well, gee. He's actually beginning to sound almost like a conservative here. He was never really a leftist. He was always kind of a centrist. But this is getting a little bit more rational. This is good. The problem is it's not a good campaign to get votes, he observed. Politicians always take the easy way out. They want to spend money and want to blame the inflation on somebody else. Well, bravo, Captain Obvious. Although he highlighted gradually rising interest rates can cause more inflation, Schiff stressed if rates were sufficiently high, inflation would come down. The relationship is nonlinear. Well, if interest rates are sufficiently high, then you actually get the bursting of several bubbles and money runs away and hides because nobody can afford to borrow it if you're not earning enough to get it back. But, well, we can't expect everything from these dudes these days. In other related news that is actually pretty good, so far it looks like the consensus of opinion at this point is that gold is going to strongly fight to hold this 1800 as a brand new floor, and it's going to stay as a new floor. And we now have more people that are positing the unlikely scenario that God may hit $3,000 an ounce next year. Gold, well, God may hit any number he wants. Gold may hit $3,000 an ounce. The goddess is looking at about 2,300 interim. And as usual, Very few people are talking about silver in this regard, but the goddess would not be surprised to see silver running around 30 to 45 by midsummer. Now, this all posits that we actually do continue to have the existing situation rather than things getting dramatically worse all of a sudden, which is entirely probable at this point in time. See many foreign economies for news on that issue because, in case you have missed it, there are now riots and demonstrations concerning horrible costs of living going on in about 94 countries and counting. And quite a few governments are getting destabilized as well. But of course, nobody knows anything about that because it ain't on the news because it's not on the news. We all know that's not on the news. It's never on the news. But here's a nice positive outlook for you for 2023. Gold prices to push above 2,000 and silver to double on its way to 50. Okay? It's going to be an interesting and exciting 2023 for gold and silver as one analyst sees prices moving significantly higher throughout the year and into 2024. In an interview with Kitco News, Avi Gilbert, founder of ElliottWaveTrader.net, said gold and silver are getting ready to rise after a 2-year consolidation period. He sees gold prices pushing solidly above 2,000, and silver could easily double to above 40 an ounce and eventually push back to its all-time highs at 50. I was taught if you didn't have anything nice to say, don't say anything at all, and that's what it's been like for gold and silver, said Gilbert. I've just been biding my time and waiting for the setup for the next rally to 2,100. Looking at gold's long-term technical picture, Gilbert said he's been tracking a 5-wave rally in gold going all the way back to the 2015 lows. Back in August 2020, we hit the top of the third wave. From then until we hit the low back in early November of this year, we basically had a 2-year consolidation in a fourth wave. We're now preparing to rocket higher in a fifth wave, he said. Gilbert added traditionally the fifth wave is fairly powerful, with potential for prices to go parabolic. Nice word, parabolic, as long as the parabol is that way and not this way. I'm happy. Gilbert trades gold through the world's largest gold-backed exchange-traded fund. No. SPDR Gold Shares, New York Stock Exchange, GLD. His minimum target for GLD in 2023 is $220 per share. It would not shock me if we went as high as $245 or $250, but $220 seems a very reasonable target at this time. However, before gold starts its major bull rally, Gilbert said he's looking for one more pullback for GLT to test support between 157 and 161, representing about a 6% decline from current prices. GLD last traded at 166.83 an ounce, roughly unchanged on the day. The next pullback will likely be a buying opportunity, and you could put stops around 155. With this setup, I'm looking at starting to get aggressive and starting to use leverage. Turning to silver, Gilbert says he sees even more potential than gold. Yeah, well, things are happening. Silver is getting set up for both a third and a fifth wave rally over the coming year and a half. Silver may replicate what we saw in 2010 and 2011. That price action was outright parabolic. Silver has lagged in the precious metal space for the last 2 years, and it has a lot of catching up to do. Nah, shit, Sherlock. However, similar to gold, Gilbert said he's looking for one more sell-off. Well, other sources I have are saying probably 2 more sell-offs before we start our moonshot. But you never know. We shall see what we shall saw in that regard. So far, the consensus is looking pretty bullish. It should also be noted that this week LME celebrated a little victory over there in London. The London Metals Exchange had been actually forced to appear before courts in front of a judge about that whole, little nickel kerfluffle some time back that everybody has conveniently forgot about and got memory hold. And, interested parties that had lost a lot of money and didn't like the cheaters cheating and people deliberately breaking their own rules to suit their own purposes were asking for some discovery.
They were looking to see some documents. They wanted to see some justification as to why the hell this whole thing had happened in the first place, in terms of breaking a bunch of rules and breaking a bunch of contracts and pissing off a whole lot of individuals, and just who was being protected. Things were actually looking a little bit positive at this point, that some answers might be found. And then a judge decided, not the only judge this week to decide that, the way judges decide, a judge decided that, yeah, they had obviously been engaging in shenanigans. There had obviously been some chicanery going on. There may, heaven forbid, have even been a little bit of random malfeasance here and there and some rule breaking. But nonetheless, the case was thrown out. That's just kind of the way it goes. You can go into a court with a bunch of evidence. Happens a lot lately. And you can show some evidence that shows that actual rules and actual laws that are written on paper were broken. But apparently, the breaking of rules and the breaking of laws of various types is not sufficient to ensure that investigations will happen. It is not sufficient to ensure that persons will get in trouble for breaking laws and breaking rules. Just funny how that works, So LME is still going on its merry way, and they still have their new regulations in place that pretty much blatantly state that as and when they see fit, they will impose limits on how a metal can move within the market in the interest of keeping the market nice and stable. And the wording is sufficiently vaguely worded that basically, they were able to slide in this total and complete bullshit. And, ain't nothing gonna happen. We shall see what we shall see. Though I will say it surprises the goddess that so many people are still willing to play in a publicly proven, publicly declared, absolute crooked market. If the goddess was a large miner and had massive amounts of metals to sell, and the goddess had a choice between a market that had been proven to be crooked and had rules that openly said they would be crooked as and when it benefited them, whether that benefits me or not, the goddess would be selling in another market, because really that's just, that's practically suppression. That's practically disenfranchisement right there. You're completely removing my ability to operate in a free market. You're disenfranchising me here, But then again, the goddess in general has a problem with suppression and disenfranchisement. Oh, and by the way, so far, according to the Arizona website, while we are still active voters down there through some massively ridiculous, supposedly entirely impossible thing, since we unregistered 3 times, apparently we didn't vote last election, so that's good. Bye.
Hello. Note to self: don't drink an energy shot before doing the sign language interpretation.
Why? Were you getting manic back there?
Yes, I was.
Oh, I thought you might be getting the shakes so people couldn't understand.
It's called a living legal system, like a living constitution. Shaggy says, have a good one.
Good night, Shaggy.
It's 8 o'clock our time, John. We started right on 6 o'clock Montana time. Anyhow, for all those coming in late, the subject of this week is basically it was freaking cold, and so we didn't get a whole lot done, except like fix some broken pipes and things like that. But we did get some results back from the uh, lab, and the latest solution we tried as an elution solution, if you'll pardon the double entendre, there it is, there we go, pretty good. We got 27% into solution in 3 hours. So we're hoping we can use that in combination with recirculation circuit and electroplating the gold out of solution as it's liberated to do a good job of stripping the resin. We shall see what we shall see. Anyhow, so I've got some steel wool that's been digested, waiting for Eva to do an assay on it. And I've got some partially eluted resin that is sitting there waiting for Eva to fire assay that. And we'll get on that tomorrow if nothing else happens and go from there. So that's basically what's happening with our research. 7 stainless steel light switch covers, stainless and nylon bolts and washers. Yeah, that would work. Each of your plates. Yeah. That sounds like it would work. Now, if you're making hydrogen and oxygen at the same time, you'd be making an explosive mixture, correct? So that would have to be kept from any kind of static charges or anything. Trust me, I know this from experience. Explosive gas mixtures are quite sensitive to static electricity. Ask me how I know. But yeah, it's interesting. Oh, Jim had something more important to do than us.
Well, yeah.
So, anyhow, so that's about it in terms of that. Haven't heard anything from Zioxio on any research he's done. 671. Well, the thing is, if you're making a mixture, then you can't get rid of it, or else you can't use it. In our case, it was oxyacetylene mixture, and it was very loud. The plastic bag made for not terribly damaging shrapnel, just got a rash. Luckily, I was wearing ear protection. But yeah, that was interesting. Better to learn about static electricity with oxygen acetylene in a plastic bag than with dynamite. Yeah, that you'd have to, Paul. Yeah, it makes sense. They would, depending on how you set it up, Jeff. You could set it up so it would do that. It sounded to me like Paul was talking about setting it up so it generates both at once for use to basically modify the air-fuel mixture a bit and get better efficiency, which I'll have to look at his information. Yeah, I know, Paul. I got it right here on my list. Right after call Eva's doctor and Solubility of thiourea, that one I looked up. 1.06 volts max for gold. And lead oxide on titanium was Mysterious Boyce at on YouTube. Now, you said 55-gallon drum liters with oxygen and acetylene. Now, were they separate? So you had oxygen in one and acetylene in the other? Or was this a blended mixture? Mine was a blended mixture. That was the problem. The slightest little static charge going off on the inside of the plastic bag initiates complete and utter combustion in a small fraction of a second, releasing large quantities of energy, which was uncomfortable as I was holding it at the time. Oh, yeah, that was an interesting night. Learned so many things. Oh. Yeah, Chris, that's a pretty tricky situation there. If you're going to do it, if you had like a weather balloon from a significant distance, put the oxygen in first, then put in the acetylene. Yeah, they are plastic bags used to line 55-gallon drums. They're basically just big plastic bags, Jeff. Yeah, you fill them with oxygen, acetylene, and you get something very, very powerful and noisy. I'm not sure exactly what the explosive energy released is, but the speed with which it releases it is pretty dramatic. And a 1-gallon Ziploc bag filled with oxygen and acetylene, when initiated, can be heard approximately a mile away. It's somewhere in the neighborhood of like a 30-06. It has a lower tone. Doesn't have a crack. It's louder than a 12 gauge. Yeah. Interesting stuff we did when we were kids. Luckily, we survived. At least most of us did. Trying to get it far enough away, Chris, that you're safe. What did you use as a timer? Oh, for something like that, just a simple safety fuse would work adequately as long as you had an initiator somewhere where it would start the mixing. That would be the problem. You need to start mixing it first. Yeah, it blew out windows several miles away. Yep. Mm-hmm. And he blamed it on the Navy? Good for you. So, yeah, you're making flammable mixtures of gases. You have to be very, very careful. When you mix them together at the end point, like say a Bunsen burner or something like that, not nearly so much. But when you mix them together and then try and transport them, it's a bomb. Anywho, so that's what we're up to right now. Hopefully, the weather looks good this week. So, if nothing else happens, we should have some more results on the Aleutian. I think the reason I didn't apparently get better recovery from the resin was I simply couldn't keep the solutions at the proper temperature while running it through the electrolytic cell I had. I have a plan B now. We'll see how it worked. Wow, really, Jeff? That did he learn how to shave his head around that time? I'm just thinking that all of a sudden he probably had the idea that would look really, really cool. Lighter to see if a piston in a snowmobile is going up and down. Mm-hmm. I actually had an employee one time was checking the fuel in a generator, gas generator with a lighter. And I mean, it was at night. It was in a dimly lit area. I had to have a very quick discussion with him about that. Not a bright idea. Although it might have gotten very bright, but not a bright idea. Oh, anyone else got any questions or news? I don't know if Lauren ever made it. I know he's fishing today. Hope he had a good time. Wasn't doing too good last I heard. Or just jam a screwdriver in there. Yeah, just put a screwdriver in and crank the engine, see if it comes up and down. Oh my goodness. Well, pretty slow, huh, Lauren? Yeah. Well, I got 2 containers of maggots. And if I remember, I'll bring them out there tomorrow. All they have was the white ones. The reds, again, I looked carefully, but they didn't have any. Chlorargyrite smelt recipe? I have no idea, although with chlorargyrite, you should be able to leach it with thiosulfate. Can you cement the copper out of the thiosulfate? Anybody? You betcha, Shaggy. Because the thiosulfate should dissolve the silver chloride, but not silver. So theoretically, you could probably do a thiosulfate leach and then just directly precipitate it. That's my guess. You added to your gold stash, huh? Had a dental surgery to remove a crown. Well, that doesn't sound like much fun, John. I think I prefer just to go down to the coin store. So if you're like first, perhaps, what would that be for? To get rid of other stuff, Chris? Yeah, well, I had a little bit too much this before the sign language interpretation. Yep, I'm going crazy, man. Just going crazy. Had all that energy. So, did it work out well? I can't tell. I'm just having fun. Eva gets annoyed if I don't do it at this point. I'm not sure why, but I think so. In the case of silver chloride, for smelting that, you generally use a lot of soda ash. It's going to eat up your crucibles too. But it's, yeah, I know, John. For me, it's just a short walk. But let's say, I presume chlorargyrite would be silver chloride mineral. And I say that's why a lot of soda ash would be the key from what I know about just plain silver chloride. Don't know what else you'd have in there, but I'd go heavy on the soda ash. No, Chris, I identify as marginally sane. I thought it was funny. I was watching a guy he was having a discussion with a woman, and they were talking about this. I identify as female sort of thing, and it was so funny because he goes, "Well, I identify as being biologically correct on this matter, and therefore it's rude for you to argue with me." Because if I identify with my opinion It demands your respect. Well, there you go. Oh, don't worry, Lars. We wouldn't do that. You know? Soda doesn't hurt silver. I say the soda ash, as far as I know, is used to help reduce the silver chloride into silver. But you're going to have some losses. I say it might be better to do some wet chemistry in terms of losses. Kodak. I don't believe that. Little one, Kodak says everybody is crazy. The only difference is flavor and extent. Are you crazy?
Yep.
Oh, I guess she says so. So you must be true.
Kodak is absolutely correct. The difference is also whether you are a well-adjusted nut.
Yeah, if you got the wrong torque on the nut, bad things can happen. No, soda ash doesn't hurt silver, to my knowledge. I mean, that Eva's flux recipes always have a significant amount of soda ash in them, and
it doesn't affect.
Yeah. No, soda ash is not potassium nitrate. It's what's the formula? Do you know, little one?
Soda ash?
Yeah, soda ash. It's basically
sodium carbonate.
Yeah, it's sodium carbonate and soda ash. See, sodium carbonate is washing soda, and it has a lot of water in it in the crystal structure. Soda ash has been heated to drive off all that water and then reground. But the active ingredient's the same. It's just you get a lot less fizzing and frothing in your crucible when you use soda ash as opposed to washing soda. Okay, but you can get something fairly similar. Just go to the store and buy washing soda. You could also use sodium bicarbonate, but it's not as effective. And again, you still have a lot more frothing. Soda ash is best, but it's not something you can get real easily. Potassium nitrate would be used if you need to oxidize something, like in our case, resin. We use some potassium nitrate to oxidize the resin in the charge. Have you tried increasing the potassium nitrate a little bit yet, little one?
Not yet.
Not yet? Okay. Well, will a pool store have anhydrous sodium carbonate, or is it going to have hydrous sodium carbonate, Chris? I presume that's what you're saying, Chris. Any pool store. Where to buy soda ash for pools? Soda ash pH increaser, 10 pound, 15.25. Sodium carbonate, but is that anhydrous? That's sodium bicarbonate. Sodium carbonate. And this is alkali. Let's see. It says sodium carbonate anhydrous.
We'll have to buy it there next time. It's probably cheaper than the chemical store.
Well, here's a 60-pound bag for $90. I think we got ours for about $70. but that seems, let's say, it's accessible at least. Yeah, saltpeter would be potassium carbonate. I mean, potassium nitrate carbonate. Jeez. Yeah, the other thing you might be able to get a pool supply would be the fine silica sand, although I think they tend to send a stock of coarser silica sand. Mount Baker appears to have burned up some of Jeff Williams' gold. Dan Hurd took his gold home to do himself. He may think like me on that. Well, yeah, they would usually have diatomaceous earth also, Chris. It wouldn't surprise me. It's usually a good idea to do small tests first when you're doing smelting stuff because variability is a thing, you know? I don't think you ever need 1600 Fahrenheit until cupelling. I don't know how hot are you using on your crucibles, little one?
For my smelts,
Yes.
yeah, they're getting at 1750.
1750 for us. We're trying to break down the resin, and at that point, it's almost carbon spheres with gold in them at that point. So yeah, we have to go pretty hot. We also need real fluidity because we're dealing with very small particles.
You want super fluidity when you're pouring. Your flux should be running like water to get a good button.
Yeah. Halides mess up on you. That wouldn't surprise me. But that's why, again, this is one thing where a lot of people screw up. Always do it in a small test first. That way, when you mess up, it only hurts a little bit. Eva doesn't use any flux thinners like, say, fluoride or whatever.
You don't have to if you've got it properly designed.
If it's properly balanced, it should be pretty thin. The problem when you use a standardized flux is that it's probably not going to be balanced for your particular situation. Eva has spent quite a bit of time tweaking the formula gently to get it to where it works pretty darn well when she's doing resin. Now, when she goes to start assaying rock, then it's going to be more experimentation again.
Actually, I already discovered, Bear, with our rock anyway, I didn't have to change the flux formula at all.
According to her, she didn't have to change it at all. Did you put a reducing agent in there?
Yeah.
You had to change it at all? Yes, you did.
I meant the proportions of the flux, not the reducing agent.
The reducing agent is part of the flux formula.
If you want to call it that way.
Yes. All the stuff you throw in there is the flux formula. Everything except what you're dissolving. I work in a charcoal forge. Sometimes I'm not liquid enough, then I crush it and pan it. Yeah, Jeff, if she's like melting like that little gold bar, actually it looks more like a gold tic tac. Like she did the other, that 7 gram button. For that's when we get up there and I think she takes it to 1960 on the pyrometer to do that. But I think that's the highest temperature you ever go, isn't it?
Yeah.
Yeah. When she's actually melting gold beads into one big gold bead. Aside from that, she's usually well below that, which is a lot easier on your furnace and your heating elements too. I'm not sure what you meant, Cougar. You work in a charcoal forge. Okay. So I guess that means you have a charcoal forge like for metalworking or whatever. Sometimes I'm not liquid enough. I presume that means you're actually crucibling in a charcoal forge. Then I crush it and pan it. Yeah, okay. I think I got it. When you're not hot enough and your flux isn't hot, isn't fluid enough, then you have to crush and pan. Yeah, that would make sense. If I got it right, just let me know. Yeah, we found that by simply I don't know. In Eva's case, she's taking it to 1750. Again, this is a lot of trial and error that she's done to see what works with the resin. Because guess what? In your assaying book from the 1930s, it doesn't have how to assay ion exchange resins.
When it comes to your flux, I have found that you want about 4 parts of silica to 3 parts borax. So I'll use like 12 grams of silica, 9 grams of borax. You want to have a minimum of 2 times the weight of your charge in soda ash.
You mean the other ingredients of your charge or your sample?
Your sample charge.
Okay.
And if you keep those constituent things at about that level, when you bring it up to 1750 to 1770, you'll usually get super fluidity. Like in a matter of a couple of degrees, it'll go to really water if it's gone through its full fusion thing.
And then when she's doing like resin stuff, she's also adding 60 grams of litharge and a gram of
60 grams of litharge, a half a gram of potassium nitrate, and a 10-gram slag cap that has been crushed to passing 60 mesh.
And she also uses 10 grams of old slag that's been crushed and put on top. But losses. In her case, as far as we can tell, the losses are fairly minimal on the direct fire assay of the resin. Mount Baker goes 2000. We have no way of verifying how accurate the thermocouple and display is on the furnace, but that's what we're using as a thermometer. Basically, it has a thermocouple and a digital display and such, and so that's what she's using to monitor the internal temperature. We have not independently verified that is in fact the internal temperature, although I have this funny suspicion that if I ask Lauren, do you have an infrared thermometer, I suspect he might say, oh yeah, right over here. Just guessing. He's got an amazingly thorough shop. He's got all kinds of gizmos, gimcracks. There's rarely a time. Oh yeah. Lauren says, yep, sure does. If you want,
well, of course, Lauren has everything. We all know that.
Oh yeah, the lead collector melts at 400. I say again, we're trying to break down the resin beads, which are basically carbon at those temperatures. We're trying to oxidize carbon, and that's and at those temperatures, the flux is not nearly as fluid. So I say that's one reason we do it, to get the flux liquid enough that everything can settle through it well. The temperature
nice,
is critical
clean
on that.
Crucibles that way.
Yeah, she's been reusing crucibles dozens of times, and they look nice and clean.
And they also they don't die as fast.
Yeah, I presume, Lauren, that your thermometer goes up into the ranges that we need for the kiln. I'm sure it does. Knowing you, it's probably maxed at 2200 or 2500 or something like that. By the way, how did the camera work today with the fish? Well, I mean, yeah, I say you can ask Lauren to borrow his thermometer and double check your pyrometer if you want, little one. You can open up your first real quick and take a look. Yeah, he's pretty. He's also very meticulous, much better than me. And I mean, when he's doing mechanical work or whatever, he's very careful to clean everything and make sure it's really in the proper shape to put back together again and such. I say he's very meticulous about doing things right, better than me. I suspect sometimes I drive him a little bit. I get annoying to him when I'm doing something because I'm a little more. I'm not usually what I call slipshod, but sometimes I cut corners a little bit.
Yeah.
You know. Yeah, if we had to spoon anything out, Paul, it would be useless for us. The little teeny pieces of metal have to settle naturally through the flux, or we're not going to get a good result. That's just the way it is.
Yeah, they collect in a button.
Yeah.
That's what the lead is for.
Yeah, if Eva sees any metal in the flux, then she has to redo it. And she does. She examines her flux every time. And
it gets weighed, it gets examined, it gets categorized and characterized, and then if I see anything in it, it is kept and rerun.
Yeah, I say she's pretty meticulous too, which is very good in an assayer. I know I had some water somewhere. Where did my water glass go? I'm getting thirsty.
On the counter.
Ah, there it is, way over here. But I'm also working under the principle that I need systems for what I'm doing that are pretty idiot resistant. They can't, if they're very persnickety, I need to find out about it before I'm doing a lot of gold. I need to know what kind of parameters, how much variation I can get away with. And in order to find that out while still catering to my natural impatience, sometimes I'm just a little sloppy. But the idea is, okay, this is about as accurate as it's going to get in real life. So, how, if that's not good enough, it's not good enough basically for a mill process. If you got to fine tune it to 2 or 3 decimal points, then you need a more forgiving process, in my opinion, at least for what we're doing. If you have a multi-million-dollar operation that has all kinds of process controls, okay, you can keep your pH within a 100th of a point or something like that. But in my situation, it's like, pH of the leach solution between 10 and 10.5, plus or minus. I mean, if it gets a little high, there's nothing much we can do about it. I mean, we're not going to add acid just to bring down the pH 0.2 of a point. The manufacturer says 11 to 11.5, but that's kind of the process. Is sometimes I don't know if you'd say deliberately sloppy, but I'm consciously sloppy, and I'm doing it to make sure. Is this a critical parameter? I've heard about older guys using lower temps and getting more gold. It'll depend a lot on the ore. There's like 40 basic flux formulas, and there's different temperature profiles and things like that. And it all comes down to what happens in the melt. In our case, where basically all we're doing is resins, we're creating little teeny beads of gold that get collected by the lead and get taken down. Now that means the flux has to be thin. Say if it's viscous, we're screwed. It simply won't work. And say Eva has done a lot of work figuring out exactly what the profile is, heat profile and the flux that works good on resin. And resin is probably a lot more consistent than ore is in general. No, we're seeing zero matte. We don't have any.
No matte.
Never.
I get clean, shiny, soft buttons quite frequently.
Yeah.
No matte.
No matte. Collect the metal in the lead, then put the heat on and keep pelling. Yeah. But let's say in our case, say it's pretty fine. When Eva pours something, smashes it, do you microscopically examine your flux, your slag every time, Paul? She does. I suggest you try it just to see what's going on and make sure that you're doing it right. Because yeah, she will, she looks, under a loop, under the microscope, checks the flux at different levels. She doesn't just like look at one piece. She's looking color, clarity, any kind of metal. Will carbon burn at 1400? Pure carbon will oxidize at those temperatures slowly. Okay.
It makes embers in my crucibles.
Yeah, but it doesn't oxidize rapidly. And that's where the potassium nitrate comes in to help accelerate that oxidation. And the litharge, the lead oxide. Are you using litharge or are you using metallic lead, Paul? Just curious. Because the litharge itself also supplies oxygen to the resin to burn it up. To get that carbon oxidized. Yeah, but when you got slag that has shots of gold in it and dendritic gold in your crucible, you didn't do a good job of getting it into the lead. I say it's, when we get her macro lens, we can do that. But yeah, I've seen shots of lead stuck in the flux because it's too thick to allow the beads to come down.
That means you've got incomplete fusion and it's too low a temperature to get full fluid.
Yeah, I say.
Full fluidation.
I don't know, how your temperature is working compared to our temperature or whatever. All I know is if you look at your, we don't pan it. We don't have time, Paul. It's done. It's a done deal. We don't crush it and pan it. We do it every time. It gets in that lead button one time. We don't have time for this. And if it doesn't, it gets remelted, because we don't have time to crush it and pan it. We have, we can remelt it. That's about it. And we're certainly not going to be doing that every time. We're doing this we're measuring to the thousandth of a gram. The scale is probably accurate to probably 3/1000ths of a gram, but that's the precision with which we're doing it. And Paul, you only pan your mistakes? Eva only resmelts her mistakes. She has very few mistakes. Again,
I've had one in the last 5 months, 4 months.
something like that. Yeah.
The one I
That
just did the
that
other
one
day.
the other day
Mhm.
was the first one that did that I can remember since you've been at Lauren's this season. It's basically first time every time. Rather than doing it at lower temperatures or for a shorter period of time, she does it at a higher temperature for the correct period of time it takes to get it all in the bottom there. And it's done. It's on to the next sample. So that's why we do that. How can you judge your real losses? First of all, statistical analysis. She tries never to do one assay on something. She always wants at least two. She'd prefer to have four, but we don't have time for that. In terms of real losses,
Mass balance.
she weighs everything. First of all, she weighs the charge when she puts it in. She weighs the slag when it comes out. She weighs the button when it comes out. She weighs
the cupels.
She weighs the cupels to see how much lead oxide is going into the cupels. So she's seeing where a lot of stuff is going. In terms of how do we judge our real losses? Well, let's say, aside from the statistical anomalies and such, we've tried, say, months of testing where different formulas on the same resin, see what maxes out, what consistently gives a good high number. Rock Butcher was able to help us at one time by actually using a X-ray fluorescence spectrometer to what is burned up. Well, if we were to ash actual resin without any pre-treatment, usually 25 to 50%. What is burned up? I don't know. You want us to send you a sample and see what you get? I can do that. What size charge do you use, Paul? What size crucible are you using? Okay. With a 110 volt heating element, a number 5 crucible. Okay, I'm not sure what size charge in total grams are you using, Paul? And that'll give me an idea how much resin to send you. Let's say if you were doing an assay with, and are you using litharge or lead? Again, that's a important question because oxidation is important here. Back to Jeff while Paul's typing in here. Is that 150 mesh lead? Is that what you're saying? Is that what the 150 means? We're using a single heating element is 19 to 20 feet of 18 gauge nichrome or canthal wire. Okay. And that will give you about the right resistance. About 10 ohms is what we're working. Okay, I'm unfamiliar with the term Merrill lead. Let me see if it's MERALLEAD. Lead. Okay, it's not showing. Okay, 150 grams of metal. Okay. That should be the equivalent of what? 25 grams dried, little one?
Yeah, probably.
Okay. Well, we can send you 25 grams of resin, and you can try it and see how it works. If yours works better than ours, that would be great. You want to do that, Paul? Eva usually winds up with a 60 grams of lead with, she's using 60 grams of litharge and usually winds up, what, 57?
57, 58 gram button.
A 58 gram button, yeah. So, yeah, I'd be happy to do that, Paul. When I was talking about 2 heating elements, Jeff, that would be for a 220 circuit. No, 150 grams, and he uses lead metal. What's your total weight of charge, little one?
About 117 grams.
117 grams.
117 to 120.
So, again, 25 grams of dry resin should work, huh? He's got 150 gram charge, and he uses metallic lead. Yeah, I know how that is, Paul. And don't worry, even when they're not worn off, I still can't hit them right. So anyhow, Jeff, as I was saying, I was thinking going 220 volts with each element being essentially a 110 volt element, 110 to neutral. And so I say 18 gauge nichrome or kanthal, Kanthol. And the length is 19 to 20 feet of it. And I coil it around a 7/16 inch dowel. And then you have to stretch it out to get roughly 3/8 of an inch between coils. So that's how I do it, Jeff. And that seems to work pretty well. The Kanthal was, I think it was like $50 for a 5-pound spool, which has like 100 feet in it or something like that. Hey, Sherry. How's it going? Yes, we are parting the beads. The we have had a resin sample assayed by a reputable assayer, although he doesn't like doing it because it's really a pain in the ass. And we also confirmed that with Rock Butcher's XRF. There's enough concentrate. When you're talking like 4+% gold, an XRF can do it. It's not very good for rock assays, but for that it worked fine. And so anyhow, what is this, Chris? Get some of that. Talk to you in a second, Sherry. I'm trying to see pure molybdenum rod. Okay, and what is this for, Chris? Is this for anodes? Holy crap, that's some expensive crap. I'm going to star it, and then I'm going to come back to you. What am I going to be using it for, Chris? Yeah, okay. Yeah, Sherry, we're doing fine here. I got really cold last week, like below -30. We got through okay. Although I'm not a big fan of having to fix pipes when it's 30 below outside. Luckily, the pipe broke where I could get to it by inside. Had to punch a hole in some sheetrock, but hell, I know how to fix sheetrock, so not a big deal. We QPEL at about 1650. Paul, I think that might be a typing error because I believe that's what you said last time was 1650.
Yes. We QPEL between.
Got it, Sherry.
We QPEL between 1650 and 1700.
Yeah, I say Eva.
You have a hot start, a long, slow drive, and a hot finish on a good cupellation.
Yeah. say she heats the crucible to 1750. Yeah, gold melts it at 1950, thereabouts. But as soon as the lead is gone from the bead, then it's time for parting or just weighing if it's the gold bead. Eva usually incorporates about 2 grams of silver so that she can part it.
I always import 2 grams.
And that usually allows for good parting. And then she takes the parting debris, wraps it in a little square of lead foil, and recupels that to get a final gold bead of a fairly high purity. Yeah, Sherry, is pretty interesting. Right now, it's oh gosh, I don't know. Why is it not giving me a number there? It says weather alert. Special weather statement in effect for Helena, Montana.
Mm-hmm.
What the heck is this? Alert details. Area of black ice and frost this evening.
Yep.
Well, whoop-de-doo, it's 43 degrees. Okay. Right now it's 43, Sherry, 43 plus. Okay. But Wednesday night and Thursday night, it dropped below negative 30. So it's been kind of yo-yoing just a teensy bit. Hey, John, I don't want it here. I'll be happy to give it away. It's possible also, again, one thing that's different is that he's always doing something different, whereas we've been doing essentially the exact same thing for 9 months straight. And that's why it's been fine-tuned, because we've had batches where we can do one after the other, try this, see what the results were, and improve it. He was done a tremendous amount of work while I was, busting rocks and crushing things and stacking stuff and lining ponds and all that other stuff. She works as many hours as I do or more. Okay.
Somebody's got to run the lab.
Yeah. Argonaut, it didn't work. Although it did alert me to the fact that there was a broken pipe. On Thursday night, when I went to bed, I left one faucet dripping warm and one trickling cold. That way, because it's these darn mixing faucets, so I don't know, how much of which is going through where. So this way I knew I got this much cold running and this much hot running. And about 1:30 in the morning, I got up to go to the bathroom, and it's like, that faucet doesn't seem like it's dripping as much as it was. So I turned it on to full cold, and it was definitely low pressure, but it had good, a decent flow at least. And on full hot, it had almost nothing. It was just barely trickling, but it was trickling hot. If there was a plug in the line after the heater, well, of course, it wouldn't be trickling hot, but there could be a plug in the line, the cold line to the heaters, or it could, and the other thing is clearly that's a cold line. So I let it run for a while, figuring if it's a partial blockage, running it as fast as it'll go for a little bit will open it up. Well, it didn't open up. So I went downstairs, and luckily the room the leak was in was empty at the time. It was also the place I needed to go to get to the valve, which was the main valve. And I thought, well, it's likely it's in the area where the water comes into the building, So I went to that area there, and when I opened the cover up, there's water running down from inside the wall, Oh, silver chloride will definitely get lost if you even if you're not too hot. Silver chloride's hard to hold. It tends to be volatile. So does gold chloride, And the gold in the resin also tends to vaporize
Silver
in many
chloride
cases.
is volatile, and I don't use it for ink work because it's more difficult to figure out the references you need for it.
Yep. But anyhow, so I was coming out the wall, so I measured, you know, from the window on the outside, and I'm like, well, it should be like in the wall behind the. We have a couple of water heaters in like a little shed outbuilding sort of thing. It should be like here. So I go in, and there was a stub pipe that was sticking out. It didn't connect to anything, but it used to be solid. When I grabbed it, it was like, no, I can just rotate this thing, slide it back and forth. I can't get it out of the wall because there's a fitting on the end. But I mean, it's loose. You know, it's not just broken; it's completely busted loose. So I went inside, measured across. It's like, you know, underneath that soffit there, boom, 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 water. You know, and luckily I had the things in my truck that I could fabric cobble a cap for it and get it screwed on with some hose clamps, you know, and so that got it for the night, cleaned up the mess so that it didn't do any more damage, and then got to sleep. And then the next day, I actually got a compression fitting and stuff. Trying to solder on a water line that's had water in it recently is an exercise in frustration. You know, that's possible, Paul. And in some ores, you're absolutely right. Say we're not dealing with a gold ore, and we've done. How many samples have you done now? Over 100 for sure.
Oh, good grief, Bear. It's a couple hundred.
I wouldn't be surprised if she's done like a couple hundred on essentially the same substance.
I average 2
Resin.
a day.
You know, yeah, she averages 2 a day. So, you know, in like 5, 6 days a week, it's been a while. Well, not when we were working this summer because we were out in the field a lot. You're only getting
Yeah.
1 or 2 days a week at the
Yeah, but
lab.
before we redesigned the furnace, I could do 8 in a day rather than just 3.
I'm sorry. Do you want it to work?
No,
Okay. You don't want it to
of course
work?
I want it to work.
Yeah.
Actually, what I want is a nice gas furnace, a real furnace. But that ain't happening.
Yeah. That's
What
it.
with parameters?
Yeah, I agree. It'd be really nice to have an unlimited budget and lots of room and a giant building and a few other little things. That would be nice. But we're dealing with reality here. Oh, yeah. Yeah, we have very small pieces of gold. Our gold is probably more almost in atomic scale in the resin. It's in gold complexes that are bonded to molecular sites on the resin. And that's why we have to use litharge so that that's right. This is Hard Rock University miners table. But that's why we use the well, let's see. We may have what you got, Sherry. What kind of thermometer? But I'll give you my P.O. box. Box 1783, right, little one?
Yeah.
59624, correct?
Yeah.
We're probably dealing more with a cyanide complex or a ferrocyanide complex or a thiocomplex. Not too much in the way of halides. I say it's kind of a complicated leaching solution. Yeah, if it's not something you got laying around that you just want to send us over here, make sure you talk to us first, Sherry, because we wouldn't want you to send anything that's not going to be exactly what we need. 'Cause I really appreciate the thought, but sometimes we need very particular things, and we do have thermometers and stuff for most of what we're doing.
Well, if the gods of mining would produce a furnace, I'd be happy.
Well, okay, if the gods of mining would produce a rebuilt engine for the truck and install it and fix the drive line and get everything perfect, then we could probably drive, and another $1,000 for fuel, then we could probably drive over to Anacortes and pick up that muffle furnace.
I know.
But I don't have that right now.
I know.
And the
Eric.
temperature is such, we can't just drive a regular truck. We have to be able to sleep in it. I'm not sure the definitions you're using, Paul. AU +1, AU +2, AU neutral.
The valence thing.
There's valence. I don't know what AU1 and AU2 are, because yellow metallic gold is just AU by the nomenclature that I'm familiar with. Okay. See what I'm saying? The stuff that we take the metallic gold and dissolve it in the solution, and that solution is not a halide solution. Let's say it's just going to be cyanide complexes, ferrocyanide complexes. Well, see, that's what I'm saying, Sherry, is Lauren's got one. Lauren's got one at the shop. So it's not a problem. Paul, people have different definitions for the same thing. The chemical nomenclature that I'm used to, for example, gold cyanide. Okay. Oh, wait a minute. Right here. Abstract. AU++, CN2. No, say AU. It'd be AU single plus, CU2 minus, CN2. Okay, so it's a 2, so each one's a -1, so that'd be an AU +2 plus E minus equals AU plus 2CN, O2 plus 2H2O plus 4 electrons equals 4OH, O2, H2O, 2E minus, OH minus, and HO2 minus. See, that's the nomenclature that I'm used to. I'm not familiar with what you're, it's like if you're dealing with kilometers and I'm dealing with miles without understanding what the other person's system is, I don't know. Possibly, but I'm totally unfamiliar with that, Paul. Yes, Chris Georgie is using the nomenclature, the naming system that I'm familiar with. Okay. And that's the nomenclature that all of these technical bulletins are written in. Yeah, I saw the David Hudson thing. And again, I can't understand. He's speaking French in terms of chemistry compared to this, and this is in German, so to speak. Without understanding the language, let's say this AU0 is metallic, AU +1 is an ion, and AU +2 is an ion seconite. That's what I understand. When you say gold 1, gold 2, like that, I have no idea what you're saying, because the definitions, I watched that. And I'm like, I can't tell what's going on here. I know what he's saying, but it doesn't correlate with any of the information I've given before. There's no correspondence there, so to speak. You know, I can, like me and Chris can be talking, and Eva's going like, I don't know what they're talking about. Chris and I understand because we're talking the same language. But she doesn't understand. See, AU0 is a halide, AU1 is the yellow metal. Okay. So how does that translate to gold cyanide? Okay. I don't have a halide. So what is gold cyanide? See, Paul? That's what matters to me because that's what I've got. I have the gold cyanide complex. I probably have a gold thio complex. I may have a gold ferrocyanide complex. I don't have a halide complex. There's nothing that I'm aware of. Chris, do you have any belief that anything in the Eco Gold X forms halide complexes with gold? I'm not familiar with anything, but you're a lot more knowledgeable on what's in it and the chemistry than I am. But do you have any idea if there's any halides in there? And for everything, listen. Yeah, exactly. A halide would be a fluoride, chloride, bromide, iodide. I think I'm missing one here. Fluorine, chlorine, bromine, iodine. Maybe not. Let me see what I got here. Fluorine, chlorine, bromine, iodine. And then it gets to weird stuff that doesn't exist in normal things. Okay. So a halide would be gold fluoride, gold chloride, gold bromide, or gold iodide. And those are common complexing agents of gold. They're just not what we're complexing it with. Yeah, and that's it. You say the guy. That's correct, Jeff. I am not sure. I mean, we have gold. Let me show you. I will show you the imaging of our gold. This is done on an electron microscope. Therefore, the term color is not, doesn't correlate well. Let's see if I can show you here. Wow, that's hard to do. Okay. See, this is a lead sulfide particle. That's a gold particle there. That's a gold particle there. There's a gold particle. The other one's iron oxide. Those are actual images, and those particles are generally in the neighborhood of 1 micrometer. First one there is, oh gosh, that was almost 50 micrometers across. The actual particle size distribution. Now this is in the ore. Yeah. There's the gold particles detected. Notice how they're all images. They're not just particle sizes. Oh yeah, rock. 1 micron. Yeah, we're looking at the
electron microscope.
The gold particle size in the rock was 80% passing 6.8 microns. Okay. This scale here, it doesn't have a scale on this particular sheet. On the previous ones, by the way, hi Rock.
Hi, Rock.
The scale is right here, and that's 20 microns for the whole scale. Okay, that gives you an idea. See? No, that's where you're wrong, Rock. That 1 micron dissolves quick. You know? Yeah, that's because I think astatine is radioactive and doesn't really exist in nature. I mean, in any quantities, you don't run into it. Hey, Rock, how's it going? You may call it AU. I call it monoatomic gold. You know, I know of Rock, but that's what I'm saying. 80% by weight, passing 6.8 microns. That's why this stuff dissolves so well. You know, that's why we have to dissolve it, and we can't gravity separate. Can you imagine how fine you'd have to grind it to liberate gold of that size? Oh my gosh. Yeah. Well, of course, monoatomic gold is not yellow metal. No, we have not tried cyanide because it is illegal in this state, Argonaut. I have run mines with cyanide and charcoal, and I have no problem with them, but the state does.
Because of the eco gold, because
Yep.
of the greenies.
No, small and done right is not legal in this state. Okay. That's right, Rock.
Greeny weenies.
Oh, I'm sure it is, Paul. Monoatomic it just means individual gold particles with single gold. You know? How close are you to start? Not close enough, Rock. That's why we're dealing with this Eco Goldex stuff that doesn't have all the information that cyanide does. Cyanide has, a century and a half of experience, major mines, universities the world over, probably billions of dollars in all that time, in constant dollars spent on research on cyanide recoveries, between universities and everything else. Not so Eco Goldex. which is what our problem is. However, Rock, I presume you just showed up, so we do have a solution here which has recovered 27% of the gold out of the resin in a measly 3 hours. So we're trying to see if we can't prove that up. Write it for you in chemistry. Are you talking monoatomic gold or whatever? Monoatomic or crystalline gold or anything like that is just going to be in chemistry. Where's my sheet? AU. That is metallic gold. If it's one gold atom or a trillion gold atoms, it's going to be that, just AU. If an atom loses an electron, it's going to be that. And if it loses 2 electrons, it's going to be that. If it's got this double plus, it can combine with 2 cyanide ions to form gold cyanide, which is soluble. It's an ionic salt, basically. And this is what's been around forever. Some of our stuff is in the form of cyanide because part of what's in our solution is the iron ferrocyanide, and I believe, if I get this right,
Actually, I think it said iron ferrocyanate in the Eco mix. Just saying.
could be. Anyhow, and that ion, I'm not sure exactly how much charge is on that. But anyhow, I think it's got a -6 charge, but I'm not sure. Anyhow, see, that's the kind of chemical notation we use. You know? Okay. Yeah, I bet you the solution kinetics are pretty slow on that, Lars. Merry Christmas, Rock. Yeah, Rock, our plan is with this is to set up an electrolytic cell because it's got to be heated. Not much, just 50 degrees centigrade. But then just set up the electrolytic cell in the same beaker on the hot plate there and see if we can just directly plate it out and see what happens. Don't know yet. We've got further testing to define that. And so I got some leach solution here for the lab to see if there's any gold in that. I've got some what I believe to be partially eluted resin, probably mainly due to temperature situations, for EVA to fire assay. And I have the residue from the steel wool digested and dried and ready for her to fire assay. Well, I'm unaware of any atom of gold that can't be analyzed by any method. Now, well, kind of by definition, if it can be recovered, it can be analyzed. You know, if it can't be analyzed, that means you can't detect it, which means you can't extract it. All a detection is a method of extraction that allows you to separate a small quantity and measure it. So if there is a separation procedure, and I forget exactly what he was talking about there in terms of separation procedure, but if there is a separation procedure that will effectively wind up with gold from the rock, and you can weigh the rock and weigh the gold, then you have analyzed it. Okay? You've now, you may not be able to detect it by any conventional or by a particular conventional technique, but I am unaware of any gold that is not detectable by any conventional technique. Okay? If you can do that, okay, Paul, I'll try and look it up. But I don't have the time to double check his math, so to speak, by recreating the thing. I was once in a situation where somebody wanted me to check something fairly similar. the guy, yeah, this whole desert here for miles and miles and miles has like 1 ounce to the ton platinum that can't be found by any conventional technique, only by our particular technique. And I said, okay, fine. How do you do it? Blah, blah. And so the guy who was asking me to check this out, I said, look, I can't tell you for sure that he's right or wrong, but I can tell you it'll cost me $50,000 to $100,000 to find out. And the conventional geologists and metallurgists will tell you that the chances of him being correct are extremely small. It's also extremely unusual to have miles upon miles upon miles of ore grade material. That's just not generally the way things happen. It varies quite a lot. So you have to be very cautious, as somebody said. I forget who it was. This is somebody that was it. What's his name? The guy with Cosmos. No, not Isaac Asimov.
Leonard Nimoy?
No, he had a thing. It was science fact only. It was called Cosmos.
Oh, I don't.
Billions and billions of
Yeah, I don't remember his name.
Yeah.
Niven?
No. But anyhow, he said extraordinary claims demand extraordinary proofs. Carl Sagan. There you go, Argonaut. You got it. And let's say when you got something that is extraordinary, then you need to be able to prove it. But if you can, you become very famous and very rich. And that's how you do it. If you can come up with new chemistry, just like they like to say in the physics people, this would be new physics, i.e., something beyond which that we understand. That's very valuable indeed. And so if in fact he could do that, one would think he could probably have become very rich. It's kind of like when people say, let's say British Petroleum bought up a free energy source and then kept it quiet so that it doesn't compete with oil. Well, why would British Petroleum want to protect all the other oil companies? If in fact they had bought it up, i.e. they've now got the rights to that technique, they've got 26 years to get a jump on everybody else exclusively with this new amazing technology. And they're going to be the people that, everyone else has to beat. If they sit on it in 26 years, anyone can do it.
Market primacy is.
And then you got to worry about somebody in your company stealing the idea and going to somebody else and selling it to them. And so to me, that argues against the likelihood that there is such a unique technique that has such amazing stuff. It took me a long time just to get the chemistry. Okay? I mean, conventional chemistry. I sincerely believe there's stuff we don't understand. Okay? But there's some stuff we seem to understand pretty darn well. And to say that the intellectual structures that we built to understand such and such is dramatically incorrect, okay, would mean it's pretty much useless. which it isn't. On the other hand, we say, I've got something, a new way of looking at something, a new way of doing something. Well, again, that's extremely powerful. It's extremely valuable. And I say, I just, it demands proof. So I'd be happy to test something if I had the time and the money to do it. Right now, I don't have a lot of money. I don't have a lot of time. If you can point me to somebody nearby who's doing it, who will say, hey, come on over, Keith, take a look at it. Be happy to look at it. But say I don't have time to learn an entirely new chemistry. Short of being able to prove something, i.e., go out there and show me a bunch of gold where nobody else can find it. Say it just, as Rock was saying, I've seen a lot of people make these claims, but I've never seen anyone come through on them. And that's my viewpoint, is like, I'll be happy to look, but I've only got so much time. We had somebody who thought there was a valuable mineral deposit not too far from here. We went out, we put a claim stake in the ground, we took some samples, and it didn't pan out. I'm sure we have losses. There's always losses. So what we're trying to do is minimize the losses in the ashing, if we can do it. The the fire assay that we did that Eve is doing, is consistent with fire assays from Hiddle, which is consistent with the X-ray fluorescence spectrophotometry results that Rock Butcher gave us. So we're pretty confident that we have a pretty good handle on that method of getting the gold out of the resin. Are there losses? Absolutely. There's no doubt about that. The question is, are they substantial losses? Are they significant losses? Yeah, that's exactly right. I say it was a nice guy. We had a good day out in the field, and it just didn't work out. I call it a plus. It's only 30 miles from here. We met an interesting person, a nice guy, had a good afternoon, saw some new stuff, and took a shot. No big deal. It just didn't work out. So I say we always, try and look at the secondaries. Like when we staked that claim up on top of the hill, oh my goodness, the views were something. That was extraordinary. We had a great time. A little tired by the end of the day, but we got 100% of our goals accomplished and had a great time. Okay, how do you detect it and extract it, Paul? I mean, as I say, I was watching the video and I couldn't make heads or tails of it, except essentially I can see something nobody else can, and I can get it and nobody else can, but I can't show you, and that, as I say, it's not convincing. David Hudson says it's a halide. Ours is not a halide. A halide means it's combined with fluorine, chlorine, bromine, or iodine. Ours is not. Are you on live chat or top chat, Rock? You got to toggle that thing at the top there to live chat instead of top chat. It filters some out. Yep, I learned to do that. That's one of the 12 different things I have to do to set up the damn stream every time. Also, this live chat replay, I got to turn it on, or else if you view the replay, you won't see a damn thing. Hey, Ned or Neville, which do you prefer, Ned or Neville? I like to use what people prefer. I know that you got two possibilities there, and so just let me know, and I'll try and use that from now on. Okay, Ned. So anyhow, there's our results over there. We got 41,000 parts per million in the resin, roughly. And when you put 10 times the amount of solution as you got resin, you're now looking at a baseline of 4,100 parts per million. And in 3 hours, the solution had 1,123 parts per million in it. So pretty good initial go. At room temperature, it didn't seem to keep doing that. So I got to set up some more tests. I don't have much specific information for you on this just yet, Ned. Hopefully I'll have more this week. I've got most of the stuff on video. And once Eva does some assays, I'll be able to put results on the video. So show you where this has this much, and this has this much, and this has this much. And so this is what happened. Right now, it's like, I don't know how much is there. I don't know how much is there. And I don't know how much is there. So I'm not sure what happened. Not nearly as interesting. I was hoping to have it for today. It didn't. So now I might as well wait till Eva gets me a few results, you know? And so that is my evil plan. See, this is the solution from that system too. Another question I'm going to have to find out, well, another couple questions I'm going to have to find out in the near term is this solution easily reusable? Can I just top it off with some more sulfuric acid and thiourea or not? Right now, they're sitting in a box because Eva is behind on the assaying due to the equipment that she has to use. She can only move so much. And that's definitely a low priority thing. We're trying to learn new things, but we've still got them. You need them for something? Okay, Rock. Thank you. Yeah, Paul, I'd love to watch that. I've been in places where things just don't seem to behave like they should. Yeah, no problem, Rock. Yeah, it's way cool, but yeah, it's definitely on the low priority list right now. Especially since I know what's in them, I can use them to calibrate other stuff at times if needed. You know, if we had somebody else with an XRF or something like that. Jeff, I would expect that it would continue at somewhere similar of that rate until it reached whatever the equilibrium is. Now, it all depends on exactly what chemistry is going on, which I'm not that familiar with. And the equilibrium could be very low. It could continue to work at those temperatures and that chemistry all the way down to where it's basically got the resin to almost nothing. On the other hand, it may stop somewhere, like when the gold in the solution gets to the same level as the gold in the resin, it might just kind of stop there. But by having an electrolytic cell in the same system, as the gold gets liberated from the resin, it'll then get plated on the steel wool and should therefore drive that equilibrium down. And if that's the situation, hopefully we'll be able to take it way down from there. Then the question becomes, is the resin reusable at that point, or can it be made easily reusable? For example, reacting it with salt, like it's what happens in a water softener. Okay. The water softener, by adding salt, a concentrated brine, it drives the stuff off of the resin and regenerates it. Whether or not that happens here, I'm not sure. It wasn't listed in the instructions. I'm going to have to ask the guy for their resin. I'm doing this with a resin that's not even their resin. It's theoretically in the same general class, a strong base anion resin. But aside from that, I don't know. Again, it's a lot more technical than I know. Okay. It's just like when somebody says, I got a 383 stroker, it's like, that would be a V8, right? You know, aside from that, I don't know. I think that's a Chevy V8. And that's about it. So that's about my knowledge of these resins. But my hope is that will naturally, if I keep the temperatures up and the chemistry right, just naturally take most of the gold off of the resin right there, and whatever it doesn't will be able to be taken off by knocking down the concentration in solution so that the equilibrium can go to near zero in the resin. Okay, Paul, you may be right. If I had time to take a semester class, I might be able to understand it. I don't, you know. I'm saying 10%, 30% sulfuric. So basically about 3% sulfuric acid. We use battery acid because I have a source of battery acid that's free. So I might as well use it. Again, because I have to deal with reality and not a laboratory in the long run. I can't, it would be much better if I could use like tap water. So I'm not worried about the minor impurities in battery acid. If they're a problem, we'll probably find out about it here. Yes, Jeff, we hope we do with just some minor tuning and stuff here. Exactly. I don't know about the thiourea and hydrochloric. I've heard of thiourea and sulfuric before. That's basically what this is. It's fairly a lot of thiourea too. It's a pretty concentrated solution, But exactly, Jeff, that's the whole idea. If we can get the chemistry and the parameters working smoothly, then we upscale it to where we can do a complete cartridge at one time. We'll put a cartridge in a cartridge holder. The solution is heated, circulated through the resin in the cartridge holder, through an electrolytic cell, reheated back up, and like that. And you just keep doing that until you strip the resin. And then hopefully you'll be able to regenerate it easily if it's not already regenerated by the process. I simply don't know. But that's the basic plan. We'll see how it all works out. As the saying goes in Hard Rock University, and. But that is the basic plan. Is that we'll have to see what we can see. The cathode is connected only to the negative. The anode would be to the positive, and it is separate. In this case, anode, cathode, and talking to people tonight, the consensus of other people's opinions is it's probably best to go to a sacrificial mild steel anode so you don't accidentally plate things like chromium and nickel onto the steel wool, which becomes a real pain to separate from your button.
So like a nail?
A nail, but you'd want something with more surface area than that. You could use a steel wool anode also, but it's going to dissolve real fast. So you want something a lot thicker. Okay.
So
I'm-
like a piece of steel strap that you cut
Or a
a chunk
pe-
out of.
Yeah, or just a piece of steel, sheet metal. You know, I'm sure there's a little scrap of something over there at Lawrence we could whip it out of. Yeah, steel wool is very standard for cathodes because it's real easy to dissolve the steel. Do you know, Rock, what they used to dissolve the steel from the steel wool when they went to the uh, refining step? Because I'm wondering whether I should use sulfuric or hydrochloric acid. If anyone else watching has an opinion on that, let me know, and the reasons why. I used hydrochloric this time because I know I generally had some chlorine ions in there on a previous test, so I used it there because I've heard that sulfuric acid is an oxidizing acid. I know nitric is, and if you use an oxidizing acid on gold when you've got chlorine atoms, ions present, then you can make gold chloride, which is soluble. If you want to, fine, Rock, but I don't think there's any urgency. I can always just do it by guess and by gosh. Try both and see what happens. I'm not terribly worried about it, but that's one of the reasons you have a lot of surface area. It's very cheap, and it's easy to dissolve the call it the base cathode away from the deposits, so that all you're left is with the electroplated deposits that you then smelt down. Yeah, just ask them what the general procedure is for dissolving the steel wool, whether it's hydrochloric or sulfuric or something else, you know. And so I not make sure I'm not making a mistake. But that's my evil plan at this point. The resin I was looking at after the thing did not look stripped at all, so I'm sure there's still a fair amount there. I know that the residue I wound up with, if I wound up with 0.2 of a gram of gold in that, I would say, okay, there's more there than I saw, which is not impossible in the slightest. But the system had about 0.8 grams of gold in it when you figure out how much was in the resin that I put into the system. No, the place I worked at, we dissolved the steel wool and then dried the sludge, mixed it with a flux, and put it in the furnace. I say it's the easiest way to separate it. You also, if you're plating things like copper or stuff like that, it will also dissolve those and get them out of your way. Maybe by using hydrochloric, you will not get the silver out of the way, and therefore, you're still got solid silver chloride. I had some solids left that weren't metallic, and it kind of looked like silver chloride flock. So I'm not sure. I also know there was some sulfur containing residue too, because when I dried it out, I mean, it looked like I had stainless steel stuff there that was pretty clean. Washed it several times in hot water. Can you just smelt directly the steel wool? Absolutely. You have to use a lot more flux. Would you rather smelt 100 grams of steel wool and 10 grams of gold, or just 10 grams of gold? It's just a matter of efficiency. It's easier to dissolve it than it is to smelt it. It could certainly be done. Yeah, there it is. just a different way of doing it. But when I was drying the residue, as soon as it started getting dry, it started getting coated with like a kind of a greenish, light greenish yellow solid, like some kind of salt or whatever. And then that would decompose under the heat, giving a sulfury smell. So I'm thinking that might be the thiourea complex. I could not rinse it away, even though it looked clean. When I dried it, it would keep doing that. But when I just kept heating it, it would drive it off. And the last time I had the hot plate turned up fairly hot so that I could get things done a little quicker, and it actually ignited and burned with a low blue flame. So my thought is I'm decomposing a compound, thiourea, and releasing sulfur, which is then burning. Yeah, but you don't want to have any little bit of it stuck to the steel rock. You want to get all that gold. Not normal gold recovery, Ned. That's normal gold recovery from copper production. Okay. If you are making copper, and specifically in this case, you're looking at smelting sulfide copper in a smelter and pouring anodes of matte copper. If it's liquid, it runs off. Yeah, try that on your windshield. It's raining. It just runs right off, right? And a certain amount sticks, you know. And as say in the case of the copper refining, as you electroplate it, I think the gold winds up in the anode sludge and the silver goes into solution and is later recovered from solution. Yeah, I say is you do get both the silver and the gold and the copper. Okay, and they go different places. The copper winds up on the cathode. I believe the gold goes into the sludge, and the silver goes into solution from which it's recovered. Not sure exactly how they recover it from solution, but they do. Either that or the other way around. The gold goes into solution and the silver goes into the sludge, but I think it's the other way around. Not sure. Been a while. Been a few decades. Actually, it's been, well, I don't know, 40 years, something like that. So,
Yeah, you might want to reread the literature.
yeah, the gold is in the slimes, is what Ned says. Yeah. So that's my understanding of it. So that's another thing when I'm dealing with this electrolytic cell, I can't just throw away any precipitates. That would be great, Paul. If you get it whipped into shape, let me know. I'd love to come watch it. Okay. In the meantime, also, if you want me to send you 25 grams of resin for you to run through your smelting process and see how well it works, just let me know. Okay. I can spare 25 grams. Just let's see, 25 grams would be, yeah, if you'll mail me back the bead. Okay, it's not my gold. Okay, so 25 grams should have almost a gram of gold in it, so that's like 60-70 bucks. So it's not my gold. Okay, I don't know if you got the address before. Did you get the address I put up for Sherry? This is 17. 5, 9, 6, 2, 4. Okay, that's my PO box. So that's return. And if you've got my email, I'm sure, Paul, right? So I'm pretty sure you have it, but anyhow, there it is. So you can send me your address and stuff, and I'll see about sending you a little packet, and then we can see the comparison between the two techniques. Because if yours works better, be happy to use it. You know, we shall see what we shall see. Anyhow, say this is what I'm working on tomorrow, is setting this one up here. Lauren, are you still here? If you are, I presume you got a little bit of steel sheet laying around somewhere. We can plasma cut a little electrode out. I'm highly confident that he does. But yeah, that one bead we made that has the, I don't know what it is, chromium, nickel, who knows what.
It's really pretty.
Generally, yes, Jeff. However, it's kind of gone to 12.5. The reason being it's heavily dependent on moisture content when you're weighing things. And Eva has come to the conclusion that she likes, if you have, see if I get this right. We start with 50 grams of damp resin. In other words, if you put resin on a screen and let it sit there for a little bit and the excess water drain off, we call that damp resin, as opposed to wet resin, which be, you got a bag of resin and it's, saturated with water. That's called wet resin. It takes about 60 grams of wet resin equals 50 grams of damp resin, which equals 25 grams of dry resin. And then she splits that in half, and that gives her two 12.5-gram samples. And that's why she likes the 12.5-gram sample. Did I get that correct, little one?
Yes, you did.
Okay.
He's the one that does not properly dry his resin before he weighs it.
No, I don't.
I have a system.
Yeah. I'm making stuff, and then once it's dry, then she can precisely weigh it. But that's why she uses 12.5 gram. Let's suppose that I have a little bit more than that in a sample and it dries out and it's now 28 grams. Yeah, just to Keith. That's me. I mean, you go to Hard Rock University, that would work too. That's just me. Not necessarily, Jeff. We just have different proclivities. You're probably better at something than I am. I'm not that good at hardly anything. I'm one of the world's best kettle corn cooks. Aside from that, I can do a lot of different things passably well. Okay. But my interest is in learning a lot of different things, which means I generally don't learn any one thing really well.
Whereas I'm learning one thing.
Yeah. And so, but that's why. Okay. And so, as I was saying, if we wound up with like 28 grams of dry resin after a test run, then she'll use two 12.5-gram samples. In terms of, one will generally be fire assayed, the other will be ashed first and then fire assayed. And I'm very good at that, Jeff. Sometimes I make mistakes. I have no idea how I even accomplished it. As witness,
Russian blue, anybody?
That's not a mistake. That's just weird chemistry I was unaware of. The other one, I have no idea how that pH changed unless I made a huge mistake that I didn't notice, which seems highly unlikely, but so does acid turning to base. I mean, I don't think I'm supposed to be transmuting stuff here. Very, very confusing. But anyhow, that last 3 grams in that case, Jeff, would go into a little bag that Eva has called miscellaneous dry resin. We don't feel confident that resin will recover gold out of solution again once it's been dried. And so she just is taking that and she'll smelt it down later.
I use it for cleaning any crucibles that do get dirty.
Yeah. Yeah, if you're using electricity to drive the gold off of something, yeah, you basically need a current flow and generally just chloride ions. Did he use some salt in there? I would think he was probably using maybe like citric acid and some salt. But yeah, the electricity strips the electrons from the gold. The gold then reacts with the chloride. Yeah, that's the problem, Paul. If you don't give all the details to where someone else can duplicate it, you haven't really proven that what you're doing is correct. Doesn't mean it isn't, but as somebody else said, I think it was Robert Heinlein, sometimes the long shot comes in, but that's not the way the smart money bets. you know? So I say, when something is non-standard or strange, it's like, okay, show me. You know, that's all there is to it. Yeah, there's people can do stuff. I have no idea how they do it, but what the heck? So anyhow, yeah, Ned. Hopefully by next couple of days we'll have some results because it's going to take Eva. Let's see, one resin assay, one thing, probably a couple days to get me the preliminary answers on the remaining resin and the steel wool debris. But, and this solution, yeah, it may take as much as a week. It all depends on what else he's doing and how it fits in with his schedule. I'll give it a try, Paul. I say I am pretty busy. It may take me a while to get to it. Just keep asking every week, and we'll see. But
Write down what he wants, and I'll make sure.
no, he already sent me the stuff. It's in my email.
Okay.
The problem is once I scroll back, Tom sent me the stuff for the kettle corn thing, and I looked at it once. It's fairly simple, but I need to look at it again and then give him some numbers and send it back. That's pretty funny, Jeff. Anyhow, I say, so that's basically where we're at right now. And hopefully I'll have some better answers in a couple of days here. It's going to take you about 2 days to get those done.
Yep.
Yeah. And
I can move them to the front of the queue and bump back everything else I have again.
Unfortunately, that's kind of the way it is right now.
Yeah.
Because I got to tell what's going on so I know what to do next.
Mm-hmm.
All righty. Any other questions or anything at this point? I'm glad you guys hung in there. Nice to see you, Ned. Thank you, Jeff. A happy new year to you also.
Happy New Year to everybody.
Do you at least have to circulate the solution? Ned, because you have moving the ions by electrostatic forces takes a lot longer than moving solution by physical impulse. In this particular case here, I'm going to have a magnetic stirrer at the bottom of the beaker to keep the solution stirring, and by having the rest of the stuff hanging up high enough off the bottom, it should keep those electrodes bathed in moving solution, so that should work out okay. Anything else? Thank you, Chris, for showing up. I appreciate it. All righty, Ned. Yeah, we'll try and get some preliminary answers by the end of the week on how this test went, and I'll be working on another test tomorrow morning. This thing should take me about an hour to set up and get going, and it should be something I should be able to leave running overnight. Thank you, Miners Table. Glad you enjoyed it, and if you ever have any questions, ask them. You see, that's what really drives the conversation. All righty. Well, you guys have a good time. Happy New Year. Keep it safe out there, especially on New Year's. A lot of drunk people frolicking about for some reason. I really doesn't ring a bell with me, but whatever. Anyhow, you guys take care. Happy prospecting and keep it safe out there.
So